alright. Whether you're in bed, driving, or letting the background noise of the world fade out for a while, you're listening to Sleepless Homo. And tonight, we go back to the moment when the Earth itself changed faster than memory could keep up, when the ice, the great sculptor of continents, began to melt, and with it, every rule of survival humanity had ever known. Around 12,000 years before the present, the last true winter of the Pleistocene began to release its hold. It wasn't a gentle spring, it was chaos in slow motion. For over 100,000 years before this, vast ice sheets had covered much of the northern hemisphere, glaciers kilometres thick grinding across Canada, northern Europe, Siberia. The world's oceans were locked up in frozen vaults, and coastlines extended far beyond what we recognise today. Then, without warning, the cold began to shatter. Global temperatures rose by nearly 7 degrees in less than a century in some regions, a geological blink. We call that period the end of the Younger Dryas, a climate event so abrupt that ecosystems barely had time to rearrange themselves. The world warmed, ice melted, and sea levels began to rise. At first it must have seemed like nothing more than another seasonal shift. But year after year, rivers grew wilder, valleys flooded, and glaciers retreated faster than any generation could remember. To the people who lived through it, small scattered bands of Homo sapiens, the sky and the ground were rewriting the laws of time. Scientists have pieced this story together grain by grain. Ice cores from Greenland showing sudden jumps in trapped air temperature, pollen records revealing forests sprinting northward, isotopes marking the thaw. And with every data set, the same unsettling truth emerges. The planet doesn't always move slowly. Sometimes it changes in pulses, violent, decisive, and permanent. The Younger Dryas began roughly 12,900 years ago, when the climate suddenly cooled again after a previous warming, likely triggered by a massive pulse of fresh water from melting ice sheets into the North Atlantic. This disrupted the ocean's conveyor belt and plunged much of the northern hemisphere back into cold. Then, around 11,700 years ago, the switch flipped again. Temperatures soared, glaciers cracked apart. In less than a human lifetime, the Ice Age ended. Imagine what that meant on the ground. Mammoths and woolly rhinoceroses grazing in the steppe tundra suddenly found themselves in wetlands and forests. The saber-toothed cats that specialised in Ice Age prey disappeared. The great megafaunal world, so stable for tens of millennia, collapsed within centuries. Many species were already stressed by hunting pressure from humans spreading across the continents, but this warming finished what the spears began. Extinction became a background sound of the thaw. For our ancestors, this was not prehistory, it was weather. They watched their hunting grounds drown and their migration paths vanish under rising rivers. They followed herds that no longer returned. In the far north, melting glaciers released enormous floods, so vast that geologists still trace their scoured paths across the land. In what is now North America, the collapse of the Laurentide ice sheet unleashed the Great Missoula floods, torrents that carved entire valleys in a matter of days. In Eurasia, meltwater lakes drained catastrophically, sending surges into the Arctic Ocean and North Atlantic, shaking the global climate like a loose gear. Archaeology rarely preserves the sound of panic, but it does record adaptation. Around this time, we begin to see people experimenting with smaller, more refined stone tools, microliths, light, efficient, replaceable. Large prey were gone, so hunting strategies shifted toward fish, birds, and smaller mammals. Campsites appeared near newly formed lakes and rivers. Mobility increased, but so did the sense of settlement. As the planet softened, humans began to root themselves in its thawed soil. To understand this world, it helps to realise that 12,000 years ago, the map of Earth was alien. The British Isles were not islands yet. They were still connected to continental Europe by a vast plain later drowned beneath the North Sea. The Persian Gulf was a wide valley crossed by rivers. Southeast Asia's Sunda Shelf formed a continent linking what are now Indonesia and the mainland. Global sea level was still about 60 metres lower than today, but rising fast. As ice sheets retreated, coastlines crept inward, erasing the habitats, and perhaps the histories of people who lived there. the sudden transformation left imprints in sediment, coral reefs, and DNA. But for those living through it, the sense of time must have warped. A person could be born into a world of steppe and ice and die in one of forests and floods. Generational memory could no longer describe the land. For the first time, humanity may have felt not just survival anxiety, but existential instability. The planet itself was changing too fast to learn. When we call this the flooded dawn, we're not using poetry. It was a literal deluge. From 12,000 to 8,000 years before the present, global sea levels rose more than 100 meters. That's the vertical height of a modern skyscraper, erased from every shoreline on Earth. Entire ecosystems and whatever stories they held vanished beneath waves. It's estimated that by the time the Holocene, the geological epoch we live in, fully began, more than 2 million square kilometers of habitable land had been swallowed by the sea. Still, humanity survived. In fact, it thrived in pockets. Genetic and archaeological evidence suggests our species was already dispersed across every major continent except Antarctica. What changed was density. The Ice Age's end scattered people into new ecological niches. Forests replaced tundra, fish replaced mammoth, and the rhythm of life slowed into seasons. For the first time, stability began to seem possible. The same warmth that ended old worlds made new ones fertile. To a geologist, this was the Holocene start. To a human, it was likely the first sense of home, the first sense that the world, though unpredictable, could be managed. And that illusion, control, may have been the seed of civilization itself. Because to maintain stability, you must first remember instability. You must plan. And planning requires more than instinct. It requires foresight, cooperation, and memory that outlives the body. It's easy to forget that advanced society doesn't start with technology. It starts with pattern recognition. These were the generations who began watching the seasons like accountants of survival. They saw which valleys flooded, which trees bore fruit, when the ice returned and when it didn't. The first science was not invention. It was observation under pressure. Today we dig through this period like forensic scientists of climate. We read oxygen isotopes from Greenland's ice, carbon signatures from stalagmites in Chinese caves, and dust layers from Antarctic cores. Each line of evidence says the same thing. At the end of the Pleistocene, Earth did not ease into the Holocene. It lurched. The warming was asymmetric. Some regions, like the North Atlantic, heated dramatically, while others remained cool for centuries. The atmospheric circulation changed, rainfall patterns shifted, and monsoon belts migrated thousands of kilometers. Humanity didn't cause it, but humanity had to solve it. One haunting piece of evidence comes from the extinction timelines of large mammals. In North America, species like the giant ground sloth, saber-toothed cat, and mammoth disappear between 12 and 10,000 years ago. In South America, extinction lags by a millennium or two, suggesting a wave moving southward. In Australia, the megafauna had already vanished earlier, perhaps victims of both human arrival and previous climatic instability. By the time the Holocene stabilised, the biosphere was smaller, quieter, and more fragile. Yet out of that fragility came opportunity. Humans were small, clever generalists. Where ecosystems collapsed, we diversified. The end of the Ice Age is not just a story of loss, it's the first recorded example of resilience on a planetary scale. Every adaptation we later call civilization, storage, cooperation, foresight, was born in those centuries of climate chaos. And it raises a quiet question. If this warming gave us our world, what did it erase before we were ready to remember? Because when continents flood, it isn't just land that disappears, it's archives. Whatever technologies, structures, or symbolic behaviours existed along the Pleistocene coasts are now drowned under continental shelves, unreachable to archaeologists. Most of our species' early chapters are literally underwater. When we look for the beginning of civilization, we may be searching in the wrong places, on land when the evidence lies offshore. The truth is, we don't know how much complexity existed in that fading Ice Age world. What we do know is that climate was the editor of the human story. It deleted entire pages and forced us to rewrite ourselves. By the time the Earth stabilised around 10,000 years before the present, the survivors were not just hunter-gatherers, They were memory keepers of catastrophe. So when we imagine the first civilization, it might not have been a city at all. It might have been a way of thinking, born of fear, observation, and adaptation to a planet thawing too quickly for comfort. Civilization, in this sense, began not with bricks, but with anticipation, with the question, what if it happens again? And maybe that's why this moment still echoes in our psychology. Every time the modern world worries about melting ice, rising seas, and abrupt climate shifts, we are replaying the same ancient anxiety. The difference is that 12,000 years ago, humanity had no control. Today, we do, but we're still deciding whether we'll use it. The melt was not just a geological event. It was the first rehearsal for the world we're now living in. A planet that can change faster than its memory. A civilization learning that the real challenge isn't surviving the cold, it's surviving the warmth. If the planet could melt this quickly, what else could it erase? When geologists talk about sea level rise, they often speak in meters and millennia, but to a coastal hunter standing on the edge of what is now the continental shelf, it would have felt immediate. A familiar bay turning into an estuary, then a gulf, then open sea within a few generations. Every hearth, every campsite, every trace of seasonal life left behind would have slipped beneath the waves almost silently. Today, when sonar scans reveal buried river valleys under the North Sea, or ancient dunes off the coast of India, we're glimpsing fragments of those vanished worlds. The question isn't whether people lived there. It's how much they learned before the ocean took their archives. Archaeologists call this the submerged prehistory problem. 90% of the world's Pleistocene coastlines are now underwater, and because early humans almost always favoured coast for food and mobility, we are missing most of their story. What if complexity, social, symbolic, maybe even architectural, grew first along those shorelines? The survivors who moved inland would have carried only pieces of that knowledge, new ways to build, to count, to organise. In the record we can still see, it looks like innovation appears suddenly around 10,000 years before the present. But perhaps we're only seeing what the sea forgot to hide. If there was an advanced society back then, it wouldn't have looked like ours. No steel, no empire, no written code, just extraordinary adaptation, people mapping tides, predicting fish migrations, carving tools fine enough to sew waterproof clothing, building shelters that could stand through a generation of storms. In its own context, that is advancement, the mastery of rhythm and environment. Civilizations are not defined by skyscrapers, they're defined by feedback loops between knowledge and survival. So maybe the right question isn't, did an advanced society exist 10,000 years ago, but how advanced do you need to be to outlive a planet in transition? Because by the time the ice had fully retreated, the only civilizations that endured were the ones flexible enough to move with the water. Every culture that followed, from the builders on the Anatolian plains to the dreamers who mapped the stars, grew from the same instinct, to remember what the flood had erased. And if our species ever finds itself facing another world that changes faster than its memory, this, perhaps, is the chapter we'll need to read again. All right, whether you're listening in the quiet of a late night or trying to make the noise of the world fade a little, you're still with Sleepless Homo. Last time the ice had begun to melt and the old world was drowning. But not everyone ran from the water. Some humans stayed, on the hills above the floodplains, along the edges of rivers that had never existed before. And what they built in that pause between chaos and calm would change everything. 12,000 years before the present, in a region stretching from the Mediterranean coast to the highlands of modern Israel, Jordan, Syria and Lebanon, a new kind of human life quietly began to take shape. Archaeologists call it the Natufian culture, but that label is a convenience, a word for something that probably never felt like a single culture to the people living it. They were still hunter-gatherers, but they were different from their ancestors. They stopped moving, or at least they slowed down. That small act, staying put, was revolutionary. For most of human existence, movement was safety, following herds, avoiding drought, outrunning scarcity. But by the end of the Ice Age, something had shifted in the Levant. The warming climate made wild cereals, barley, einkorn and emmer, grow thick in the valleys. Gazelles, deer and birds became abundant. There was enough to live in one place for months, even years. And when you stay long enough, you begin to build differently. You stop seeing the landscape as a path and start seeing it as a map. Excavations at sites like Ain Malaha, Wadi Hammer, and Jericho reveal a world on the edge of change. Circular stone huts with plastered floors, hearths still black with soot, grinding stones worn smooth by years of use, middens, ancient garbage heaps, filled with fish bones, shells, seeds, and ash. These were not temporary shelters. These were homes. People buried their dead under the same floors where they slept. They returned year after year to the same spot, rebuilding walls, reusing tools. It was the first faint rhythm of permanence, and permanence has consequences. Once you stop chasing your food, time itself becomes measurable. You notice seasons in new ways. The right week to harvest wild wheat before it shatters. The best moment to set traps for migratory birds. You start storing things. Dried meat, seeds, memories. Archaeologists find stone mortars carved from basalt so heavy they were never meant to travel. Some are 1/2 metre across, still pitted with the grind of ancient hands. This was labour invested in place, a sign of trust that tomorrow would look roughly like today. The Natufians were not farmers yet. They didn't sow fields or domesticate crops, but they were already changing plants. Wild cereals collected repeatedly in the same area begin to evolve under human pressure. The people who harvested the biggest, easiest to reach grains spread those seeds unintentionally, favouring mutations that didn't drop their kernels as quickly. Evolution began to listen to culture. It was, in a sense, the first whisper of agriculture. What's remarkable is that these people weren't forced into innovation by scarcity. They were surrounded by abundance, and abundance gave them time, the rarest resource in prehistory. Time to experiment, to decorate, to bury, to remember. In a cave at Hilazon-Takatit in western Galilee, archaeologists uncovered a burial that feels almost modern in its symbolic depth. A woman, elderly by ancient standards, was buried with over 80 tortoise shells, a boar's jaw, an eagle's wing, the pelvis of a leopard, and the bones of a wild cow. The arrangement suggests ritual, not necessity. Whoever she was, healer, elder, shaman, she was honoured with a ceremony that required coordination, cooperation and meaning shared beyond survival. Such finds force us to expand our idea of what advanced means. If civilization is defined by architecture, trade or writing, then the Natufians don't qualify. But if civilization is the ability to think symbolically, to plan, to invest emotional labour in others, then they were already on the road. They created cemeteries, built shrines with carved stones, and wore ornaments made of shells carried from the Mediterranean coast to inland valleys. Their network stretched hundreds of kilometres. They knew who they were and where they belonged. You can almost imagine the evenings. Small communities of 20 or 30 people, gathered around fires near the threshold of permanent dwellings, children grinding grain while elders told stories about the glaciers that once covered the mountains. The air warm and heavy with a scent of wild thyme. They were the last generation to know the world as purely natural and the first to start shaping it. When archaeologists study their bones, another clue emerges. Many Natufians show wear patterns on their teeth and joints, consistent with grinding and repetitive labour. Their diets were still varied. Gazelle, fish, cereals, but the work of processing plants was intensive. Sedentary life had costs, crowded living, waste build-up, disease. Yet they didn't return to nomadism. Something about staying felt right. It may be that stability itself became addictive, the comfort of familiarity, the sense of territory. In the archaeological layers, we can see this gradual tethering of humanity to geography. The earth and its people were beginning a long negotiation that would end in cities. From the perspective of deep time, the Natufian experiment lasted only a few millennia, but it set a precedent. Their semi-sedentary villages appear precisely at the climatic sweet spot following the Younger Dryas, when rainfall increased and vegetation exploded. Then, as the climate shifted again around 10,500 years before the present, many sites were abandoned. The rhythm of plenty ended. But the idea of settlement, of continuity, remained. Later Neolithic farmers would inherit that logic. Stay, plan, build, adapt. Some researchers argue that the Natufians were the first to build structures used collectively rather than individually. At sites like Ainon, circular buildings with thick walls and central hearths suggest communal spaces. They might have been used for storage, ceremony, or council. Social architecture was emerging, the sense that cooperation required a physical centre. For the first time, the human mind was drawing blueprints not just for shelters, but for societies. What makes this story strangely moving is how little technology was needed. No metal, no wheel, no writing. Just trust in the future. Each generation built slightly better, ground their tools smoother, buried their dead with more care. That slow accumulation of behaviour is what we later mistake for sudden revolutions. But revolutions are rarely sudden. They are simply the moment when the slow becomes visible. We can't know what they called themselves or how they imagined the world, but in the flint and limestone of their homes, in the shells worn around their necks, and in the graves they dug for their loved ones, there's an unmistakable voice of continuity. They were no longer simply surviving the Ice Age, they were defining the Holocene, and in doing so they left us a question that still lingers beneath every city and farm. Was civilization born from desperation, or from the quiet luxury of stability? Because what the Natufians discovered is something we often forget, that comfort can be as transformative as crisis. When the environment finally stopped collapsing, humanity didn't simply rest, it began to invent. The first villages were not fortresses, they were memories turned to stone. The first innovation was not a tool but the realization that tomorrow might actually come. And perhaps that is what advanced really meant 10,000 years ago. Not machines or monuments, but the courage to stay still long enough for memory to take root. Every field, every city, every ritual that followed came from that simple, dangerous idea that permanence was possible. The Natufians tested it first, and in their quiet experiment, the architecture of everything that came after was already hidden in the soil beneath their feet. Tonight we're standing on a hill in the southeastern Turkey, looking at the first great mystery of the Holocene, a place built by people who shouldn't have been able to build anything like it. A sanctuary older than the first villages, older than farming, older than writing. Its pillars rise from the dust of 11,500 years ago. Its name is Göbekli Tepe. And the question that still echoes through every trench and photograph of that site is simple and impossible. Who builds temples before houses? When archaeologists first began uncovering those massive T-shaped stones in the 1990s, they realized almost immediately that something didn't fit the story we thought we knew. According to the textbooks, permanent architecture came after agriculture. People needed stability, food surpluses, and division of labour before they could organise such complex projects. But the radiocarbon dates from Göbekli Tepe said otherwise. The site was built around 11,500 years before the present, long before the first farms. Its creators were hunter-gatherers. They had no pottery, no domestic animals, no villages. And yet, they carved limestone monoliths weighing up to 16 tons, transported them across hills, and set them upright in circular enclosures precisely planned and aligned. The sheer physical scale is astonishing. The main rings, known by archaeologists as enclosures A through D, each contain massive central pillars flanked by smaller stones, arranged in near-perfect symmetry. Many are over 5 meters tall. Their surfaces are covered in relief carvings of animals, foxes, boars, vultures, snakes, scorpions and cranes, rendered with astonishing skill. The imagery is not random. Each enclosure seems to follow a symbolic order: predators, prey, carrion birds, abstract patterns of hands and arms. 2 of the tallest pillars, set face to face in the centre of the main ring, are stylized human figures. Shoulders, hands clasped in front, belts carved with animal motifs. They stand like guardians, silent and impossibly ancient. This was not a camp, it was a monument, and it forces us to confront a strange truth about our species. Sometimes we organise around meaning before we organise around food. Whatever happened on that hill demanded coordination of hundreds of people. Limestone was quarried from nearby bedrock using flint tools. Blocks were shaped, moved on sleds or rollers, and raised using ropes and ramps, techniques we usually associate with much later civilizations. The work required planning, communication, and shared purpose. For hunter-gatherers to achieve this, they must have already formed large social networks, perhaps seasonal gatherings where groups came together for ritual and alliance before dispersing again. Göbekli Tepe may have been the first meeting place in human history, built not for living, but for remembering. Archaeologists still debate what exactly it was. Some call it a temple, others a ceremonial site, others a feasting ground or astronomical marker. There are even interpretations suggesting it was a place to process death, an open-air cathedral of bones and vultures where the boundary between life and decay was ritually explored. The carved vultures and headless human forms hinted excarnation practices, the laying out of bodies for birds before burial. In this view, Göbekli Tepe becomes not just architecture, but metaphysics carved in stone. Every pillar carries not just animals, but geometry, intersecting lines, chevrons, and repeating symbols that might represent stars, rivers, or social emblems. Some researchers have proposed that the site encodes constellations, aligning with Sirius or the Milky Way, suggesting that skywatching had already become part of human ritual. Others argue that those theories stretch the data too far. The truth is, we don't know what the builders saw when they looked up, but we do know they were looking. The carvings are not utilitarian, they are cognitive. This was art as architecture, worldview made visible. One of the most revealing aspects of Göbekli Tepe is not just what was built, but what was buried. Each enclosure was deliberately filled in with stone rubble after it was used, almost as if retired ceremonially. New enclosures were then built nearby, repeating the process over centuries. It's as if the people who made them understood impermanence but sought permanence anyway. The entire mound grew layer by layer, a memory hill built from its own ruins. That cycle, build, use, bury, rebuild, feels eerily familiar. It's the rhythm of civilization itself, already encoded in the Neolithic imagination. When you look closely at the carvings, the animals are not random decoration. They are precise. Foxes appear frequently, often near depictions of human forms. Snakes coil along the edges of pillars, sometimes interwoven with birds. The repetition of certain species may reflect clan symbols, seasonal markers, or mythic stories. We can't translate the language, but we can feel its coherence. This wasn't art for art's sake. It was communication across generations. To modernize, the scale of effort raises a simple logistical puzzle. Why build such a thing? What could motivate mobile foragers to commit thousands of work hours to a project that yielded no food, no shelter, no obvious advantage? The best answer may be that it created advantage indirectly. Shared belief systems and monumental tasks forge alliances. Ritual is social glue. People who build together become more than survival units. They become communities. Göbekli Tepe could have been the engine that transformed scattered bands into structured societies. Paradoxically, the temple may have invented the village, not the other way around. Excavations have revealed tens of thousands of animal bones, mostly gazelle, wild cattle, and aurochs, suggesting large feasts took place there. Imagine hundreds of people gathered seasonally, bringing food, stories, and craft materials from miles away. In that sense, Göbekli Tepe may have been a prehistoric festival ground, a place where myth was sung, alliances renewed, and identity reinforced. The act of gathering itself might have been sacred. What makes the site even more haunting is that it was eventually abandoned and buried completely by its own builders. The hill was smoothed over deliberately, the pillars entombed. By around 10,000 years before the present, the site fell silent. Why? Climate change is one possibility. The shift toward drier conditions made the region less habitable. Another is cultural evolution. Once true villages and agriculture took hold nearby, the old ways lost meaning. The people who had built their gods in stone now found themselves needing to feed those gods with crops. Religion, in a sense, had created the economy. When German archaeologist Klaus Schmidt, who led the excavations until his death in 2014, was asked what Göbekli Tepe meant, he often replied, "It was a cathedral on a hill." But he also reminded everyone that we still understand only a fraction of it. Most of the site remains unexcavated beneath the mound. Ground-penetrating radar shows dozens of additional circles waiting underground. We are literally standing on top of unanswered questions. For now, Göbekli Tepe stands as the oldest known example of monumental architecture on Earth. It predates Stonehenge by 6,000 years, and the pyramids by 7,500. Its existence rewrote archaeology's timeline, proving that spiritual and symbolic life did not wait for agriculture or urbanization. It came first. Humans sought meaning before they sought stability. In that sense, the pillars are not just stone. They are the fossilized thoughts of minds that decided survival wasn't enough. It's easy to see those pillars as alien or miraculous, but they are neither. They are human, achingly so. Each chisel mark is a choice to believe that memory deserves shape. Each relief is a sentence in a language we've forgotten how to read. And if we squint at the pattern of history, we might see that this was the beginning of something larger. Not just civilization, but the idea that ideas themselves could outlive their makers. So who built temples before houses? The same kind of humans who build cathedrals before solving hunger, who write poetry in times of war, who carve art into stone when they could be carving tools. In other words, us. Göbekli Tepe isn't a mystery from another species. It's the oldest mirror we've ever found, reflecting a mind that already thought in symbols, already longed for permanence in a world that kept melting away. Tonight, the map itself is melting. The Earth is reshaping its memory, coastlines unravelling like old fabric. From 11,500 to 10,000 years before the present, the ice retreated for the last time, and the sea began to rise, not inch by inch, but metre by metre, pulse by pulse. And with every pulse, the edges of the human world disappeared. When the coastlines vanished, what stories drowned with them? At the end of the last glacial period, the world's climate entered a phase of sudden acceleration. Scientists call this interval Meltwater Pulse 1b. It was one of the most dramatic sea level surges in recent geological history. A 20-metre rise compressed into just a few centuries. To imagine that in human terms, an entire shoreline retreating faster than a lifetime, rivers widening every generation, islands dissolving into the horizon. The cause was simple but vast. The final collapse of the great ice sheets that had dominated the Northern Hemisphere. The Laurentide ice sheet in North America, the Scandinavian Shield and the remnants of the Antarctic and Greenland glaciers all released their meltwater into the oceans. The result was a planetary rearrangement of coastlines, an erasure of the world's most habitable zones. The numbers themselves are staggering. Between roughly 11,500 and 10,000 years ago, global sea levels rose more than 20 metres. The ocean swallowed more than 20 million square kilometres of land, the size of all of modern Europe and North America combined. The continental shelves, once wide grasslands teeming with life, sank under waves that would never recede. We tend to think of land as permanent, but during this time it was anything but. Maps of the late Pleistocene look unfamiliar. The British Isles still fused to Europe by low plains, the Persian Gulf a fertile river valley, the South China Sea a vast tropical continent. Humanity's first coasts were not where we find them today. They are buried under silt and salt water, unreachable except by sonar and imagination. When the ice melted, it didn't just release water, it released pressure. Glacial rebound, the slow upward flexing of the Earth's crust, caused earthquakes and volcanic activity to ripple through once frozen regions. The planet was adjusting to its own weight loss. Ocean currents shifted. The Atlantic circulation, long weakened by meltwater floods, found a new equilibrium, stabilizing the global climate and ushering in the Holocene, the epoch we still inhabit. But for those living through it, stability must have felt like anything but. Archaeologists and oceanographers now work together to reconstruct that vanished world, a field sometimes called submerged prehistory. Using sonar mapping, core sampling and underwater excavation, they can trace the ghostly outlines of ancient rivers, dunes and lake beds beneath the seas. Each discovery is a glimpse into a time when humanity's main highways were not deserts or mountains, but coastlines. These lowlands were the richest habitats of the Ice Age, mild, well-watered, and filled with resources. It is almost certain that early humans settled along them, which means that most of our species' earliest permanent camps, villages, and meeting places are now underwater. 90% of all prehistoric coastal sites older than 10,000 years are gone, submerged beneath the continental shelves. Take the northern plains that once connected what is now England to mainland Europe, a drowned landscape modern researchers call Doggerland. 10,000 years before the present, it was not an ocean but a world of rivers, forests and herds of reared deer. People lived there, fished its rivers, hunted on its meadows. As sea levels rose, the North Sea advanced, swallowing it piece by piece until nothing remained but scattered islands. Today, trawlers occasionally pull up the bones of mammoths and Stone Age tools from the seabed, a quiet reminder that Europe's first frontiers lie below the waves. Half a world away, the same transformation was unfolding on an even greater scale. The Sunda Shelf, a broad landmass that once connected mainland Southeast Asia with Indonesia, vanished beneath the rising waters of the Indian and Pacific Oceans. The region's tropical plains and river valleys became what we now call the Java Sea, the South China Sea, and the Gulf of Thailand. Before the flood, it had been a single vast ecosystem where humans and animals migrated freely. Afterward, it fractured into thousands of islands, reshaping the biological and cultural map of Asia. The genetic and linguistic diversity of that region today may still echo the fragmentation of those once unified coasts. And far to the north, another land bridge disappeared, Beringia, the great corridor between Siberia and North America. For tens of millennia, it had been a frozen steppe where mammoths, horses and humans crossed between continents. When the seas rose, it vanished, sealing the two worlds apart. The first Americans had already crossed, but the connection to their ancestral homelands was gone. By 10,000 years before the present, isolation had become geography. In each of these drowned worlds, there must have been people watching the water climb. It wouldn't have looked like a single flood. It would have looked like a long, unstoppable migration of the sea. Every generation would have moved camps slightly inland, rebuilding, adjusting, pretending that the shoreline was fixed again, until it wasn't. Archaeological modelling suggests that even a few centimetres of rise per year could destroy coastal marshes and change river paths, displacing thousands. The Earth was teaching humanity one of its oldest lessons: the coast never stays still. For modern science, the evidence of these changes lies not just in their fossils but in physics. Coral reefs record ancient sea levels through their growth bands. Ice cores capture the isotopic signature of meltwater pulses. Sediment layers in deltas preserve abrupt shifts from terrestrial pollen to marine shells. These are the archives of a planet in transition, and they tell a consistent story, one of speed, scale, and silence. Because water leaves no ruins, it leaves absence. When we speak about civilization emerging later in the Middle East, in Mesopotamia or Egypt, it's easy to forget that those regions were shaped by this same flood. The valleys of the Tigris and Nile were once much broader. Their deltas pushed farther into now submerged plains. What we call the cradle of civilization might just be the surviving lip of a much older world. The coastlines of the Pleistocene were the corridors of human movement, and their disappearance fragmented populations, isolating some, compressing others. The world's diversity, the way cultures, languages and technologies branched and diverged, may owe as much to these drowned migrations as to any later invention. Today, when marine archaeologists send sonar pulses across continental shelves, they are searching for the outlines of this lost geography. Buried river channels cut into the seafloor, ancient dunes, lake basins, even the faint traces of hearths or post holes under silt. A few finds have emerged: stone tools off the coast of Western Australia, hearth charcoal beneath the English Channel, and prehistoric camps on submerged ridges in the Persian Gulf. They are fragments of a global archive we have barely begun to open. And yet, the deeper truth might be philosophical rather than geological. Humanity's first great catastrophe wasn't war or famine, it was the loss of memory itself. The flood took not just lives, but landscapes of meaning. Entire mythologies, languages and technologies may have vanished without a trace, leaving behind only hints in the genetic and archaeological record. When we look out over an ocean today, we're also looking at a museum we can't enter. What makes this period so haunting is its familiarity. We're again living in a time of rising seas, watching coastlines shift and maps rewrite themselves. The difference is that we know it's happening, and we can measure it. But emotionally, it may not feel so different. The same disbelief, the same slow recognition that the edges of our world are temporary. So when we ask what stories drowned with those early coasts, we're also asking something about ourselves. How much of our civilization depends on the illusion of permanence? The people of the early Holocene learned to adapt to a planet that moves, to rebuild without bitterness, to carry memory inland when the sea demanded it. Perhaps the real legacy of the Meltwater Pulses isn't what they erased, but what they forced humanity to invent: resilience, migration, and the idea that home can move. Whether you're lying awake in the dark, driving through rain, or just needing a story that moves slower than the world, you're listening to Sleepless Homo, and tonight we're walking across a place that no longer exists. A landscape once covered in grass and rivers, now hidden beneath the waves of the North Sea. For thousands of years it was one of the richest environments in Europe, a bridge between worlds, a home to herds, forests and people who fished its lakes and walked its valleys. Today we call it Doggerland. But once it was simply the heart of a country that vanished. Was Northern Europe's first civilization erased by the tide? Between 10 and 8,000 years before the present, the waters that had been rising since the Great Melt finally reached the low plains, stretching between what we now call Britain and the rest of Europe. For most of the Ice Age, the sea had been trapped in ice sheets, leaving behind an immense landmass that connected modern Denmark to eastern England. It was no barren tundra, it was lush. The last cold steppe had long given way to forests of birch and pine, crisscrossed by rivers and lakes. Mammoths were gone, replaced by red deer, elk, and wild boar. It was a green country threaded with life, a continental bridge that stretched for hundreds of kilometres. Archaeological evidence shows that Mesolithic people lived there. Hunter-fishers who built seasonal camps along rivers, made microlithic tools and followed herds through the wetlands. Their world was rich in fish, fowl and plants. The climate was temperate, the soil fertile. If you were alive then, it might have seemed like the safest place on Earth, a country perfectly balanced between land and water. But that balance was temporary. As the ice sheets continued to melt, the North Sea began to fill. Around 9,000 years before the present, rising water broke through the natural barriers in the English Channel, turning the lowlands into an inland sea. And then, slowly but inevitably, Doggerland drowned. The process wasn't a single catastrophe. It was a drawn-out exile. Each generation watched the shoreline creep closer. Villages were moved, camps rebuilt on higher ground. The low valleys turned to marshes, then tidal flats, then open sea. Finally, even the highest hills became islands, and then they too disappeared. What remains today lies buried beneath tens of metres of sediment, unreachable except by sonar, core samples, and the accidental discoveries of fishing trawlers. Those trawlers have given us strange gifts. In their nets mixed with modern fish and shells, they sometimes haul up the bones of elk, bears or mammoths, creatures that once roamed freely across that lost continent. They've also dredged up stone tools, antler harpoons and fragments of worked flint. Each artefact is a small, drowned memory. In the 1930s, fishermen near the Dogger Bank brought up a barbed antler point still sharp enough to pierce skin. Later finds included traces of hearth charcoal preserved in submerged peat, and even human bones stained dark with age. These objects prove beyond doubt that Doggerland was inhabited, not a myth, but a real world erased by the rising sea. In recent decades, advances in marine archaeology have begun to reveal its shape in astonishing detail. Using seismic surveys originally designed for oil exploration, scientists have mapped river channels, floodplains and ancient coastlines beneath the North Sea. One river system alone, now called the Shotten River, was nearly as large as the Thames. Computer reconstruction show that around 10,000 years before the present, Doggerland stretched from what is now northern Britain to the Netherlands, a continuous expanse of fertile plains larger than modern England. It would have been one of the most hospitable places in post-glacial Europe. The story of Doggerland is not just a curiosity of geography, it is a story about memory and loss. The people who lived there must have had names for the rivers, the hills, the places where the fish were best and the deer most plentiful. And then, within a few lifetimes, those places were gone. There are hints that the final blow came suddenly, Around 8,200 years before the present, a massive submarine landslide off the coast of Norway, known as the Storegga Slide, triggered tsunamis that swept across the North Atlantic. The waves would have rolled straight into the shallow North Sea, inundating the last remaining lowlands. To anyone watching from the hills, it must have looked like the sea itself had risen in anger. After that, only the Dogger Bank remained, a sandbar marking the crest of what had once been the Central Plain. By 7,000 years before the present, even that was an island. Within a few more centuries, it was gone entirely. The North Sea, as we know it, had arrived. Britain became an island, Europe lost its northern heart, and one of humanity's great landscapes vanished beneath the tide. In recent years, new technologies have started to give that world back, at least in fragments. Sediment cores drilled from the seabed contain pollen, seeds, and insect remains that tell us what Doggerland looked like season by season. DNA extracted from ancient sediments, the field known as environmental DNA, has revealed traces of red deer, beavers, and even humans. It is the first time scientists have recovered genetic fingerprints from a land that no longer exists. Each molecule pulled from the mud is a line in a book the ocean tried to erase. From those traces, a picture begins to form. The people of Doggerland were not primitives clinging to survival. They were skilled navigators of a dynamic environment. They built boats to cross the widening rivers, used fish traps woven from reeds, and hunted efficiently across shifting wetlands. Some researchers even argue that this adaptability, living at the boundary of land and sea, prepared their descendants for the coming of agriculture and permanent settlement. Doggerland, in this sense, was a training ground for civilization. But for all our reconstructions, there is something we can't recover: the experience of watching your world disappear. To live on a landscape that shrinks every year is to exist in permanent uncertainty. Did they understand that the sea would not stop? Did they tell stories about it, warn their children, or see it as the will of unseen forces? We can't know. What we do know is that the memory of loss travels well. When the survivors moved inland, they carried with them not only tools and skills, but perhaps the first deep sense of impermanence, the knowledge that even continents can die. Today, divers and sonar technicians continue to explore the North Sea floor, tracing ancient shorelines and recovering fragments of the drowned forests. In some places, tree stumps still stand upright, rooted in clay beneath the silt, a sunken woodland frozen in time. It's haunting to think that each of those trees once stood under open sky, casting shadows on a land full of voices. Somewhere beneath those waves lie the hearths where people sat and talked, the footprints of children in soft mud, the bones of animals that fed them. All of it, buried, quiet, unreachable. For modern Europeans, Doggerland is a strange kind of mirror. It reminds us that our history doesn't begin on stable ground. The idea of a permanent homeland is, geologically speaking, an illusion. The first Europeans lived on a continent that changed shape every century, a living map. They adapted, moved, rebuilt, and forgot. And in that forgetting, they became us. The study of Doggerland is still young. Each new core sample adds a sentence, each sonar map another page. Perhaps one day we'll find more direct evidence of the people themselves, tools, dwellings, maybe even art, preserved in anaerobic mud. Until then, we're left with the quiet paradox of archaeology. We know a world existed because we can't see it. The absence itself is proof. So when we look across the choppy waters of the North Sea today, we are really looking into deep time, into the reflection of a country that fed and shaped the first Europeans. Its hills are now sandbanks, its rivers are shipping lanes, its forests are shadows in sonar scans. And somewhere under that cold grey water lies the memory of a civilization that stood still long enough for the tide to find it. We're standing in the middle of what looks like an ocean of sand, but wasn't always one. There was a time when this place was green, when rivers crossed the dunes, when lakes the size of seas shimmered under monsoon skies, and when humans and animals shared a landscape so alive it's almost hard to imagine. What if the Sahara once looked more like the Nile? Between 9,000 and 6,000 years before the present, Northern Africa experienced one of the most extraordinary transformations in Earth's recent climate history. It's known to science as the African Humid Period, and to those who lived it, it must have felt like a miracle. After tens of thousands of years of desert and drought, the monsoon shifted northward, bringing rain where there had been none. The Sahara bloomed. Grasslands spread across what are now dunes, rivers flowed between the highlands, and lakes filled the basins that are today some of the drier spots on the planet. What we think of as an eternal desert was, for several millennia, a network of wetlands, savannas, and freshwater seas. The cause was orbital. Earth's slow wobble, its precession, tilted the northern hemisphere closer to the sun during summer, intensifying monsoon circulation. Warmer oceans and higher humidity pushed storms deep into the continent. Satellite imagery, combined with ground surveys, reveals traces of this ancient hydrological web. Dry channels that were once mighty rivers, buried deltas, and the outlines of vanished lakes still visible from space. Among them were some of the largest inland bodies of water in Earth's history, including Lake Megachad, a freshwater sea nearly the size of modern Germany, and Lake Tritonis, remembered faintly in later myth. Around these lakes, people thrived. Archaeologists have found fishhooks carved from bone, harpoons, pottery decorated with wavy water patterns, and campsites filled with fish bones and hippo remains. For generations, humans lived not as wanderers of the desert, but as settlers of a green world. The Sahara became a continent of lakeside cultures. Herds of cattle grazed where sand now lies sterile. Hunters stalked gazelle and antelope along riverbanks. The air would have been heavy with moisture, the smell of rain on warm dust, the cries of birds that no longer cross these skies. Rock art found across the central Sahara tells us what this world looked like through the eyes of its inhabitants. Thousands of engravings and paintings, etched into cliffs, painted with mineral pigments, show not dunes, but life. Elephants, giraffes, crocodiles, cattle, fish, and boats glide across stone panels. At sites like Tassili Naja in modern Algeria and the Enedi Plateau in Chad, entire canyons are filled with scenes of hunting, herding, and dance. Some show longhorned cattle being led by humans with ropes, the earliest known depictions of pastoralism in Africa. Others portray figures swimming, suggesting not fantasy but memory, people recording what they truly saw. The precision of these paintings suggests observation, not myth. The artists captured animal anatomy, movement, and even behaviour with skill. One recurring image is that of boats, simple, curved vessels that appear in contexts far from any coast. For years, archaeologists dismissed these as symbolic, but new studies of paleolakes and their depth suggest that they might be literal. The people of the Green Sahara may have practiced early forms of navigation across inland seas, moving between islands and fishing grounds long before the idea of oceanic sailing. The story of these people is not just ecological, it's social. Excavations show a gradual transition from mobile hunter-fishers to semi-sedentary communities. In places like Nabta Playa, near the southern edge of the Sahara, people began building stone circles and ceremonial structures aligned with celestial markers, perhaps tracking the seasons and the return of rains. They buried cattle in elaborate stone-lined graves, hinting at ritual significance beyond simple herding. Each site adds a layer of complexity: symbolic behaviour, seasonal planning, cooperation. What stands out is that these developments happened in parallel to the great shifts occurring elsewhere, in the Near East, in Europe, in Asia. The African humid period was not an isolated event. It was another experiment in human adaptation, another answer to the question of how to live when the earth changes. While other regions turned to farming, the people of the Green Sahara turned to water and movement. Their knowledge of seasonal rainfall, animal migration, and lake ecology was a kind of science, built not in writing but in survival. Then, slowly, the miracle ended. Around 6,000 years before the present, the monsoon began to retreat southward. The precession cycle shifted again. The rains failed more often, and the lakes began to shrink. What had been marshes turned into dustpans. Herds dwindled. Rivers dried into sand. Within a few centuries, the Sahara's green skin peeled away, revealing the desert we know. The transformation was as profound as it was rapid. Geological cores from Lake Megachad show layers of sediment changing abruptly from freshwater clays to arid sand. Pollen records tell the same story. Dense grasslands giving way to sparse shrubs, then to nothing. The people adapted for a while, clustering around the last water sources, digging wells, following the retreating monsoon. But the desert eventually won. What happened to those societies when the land dried is still being pieced together. Some likely moved south, following the rainfall into the Sahel and the valleys of Central Africa. Others may have migrated north into the Mediterranean's coastal fringes, carrying with them memories of abundance. The disappearance of the Green Sahara was not just the death of an ecosystem. It was a dispersal of knowledge, of languages, and of stories that once described a world full of water. In a few places, that memory remains carved in stone. The rock art of Tassili N'Ajjer, for example, spans thousands of years of environmental change. The earliest images show the full splendour of the humid period, rivers, fish, and animals of the savannah. Later layers depict camels and dry landscapes, signalling the final desiccation. It's as if the artists were chronicling their own extinction, the drying of their world stroke by stroke. The paintings are not just art. They are climate data rendered by human hands. Today, satellite missions and paleoclimate studies confirm what those artists saw. Beneath the Sahara's dunes lie the ghosts of rivers. Some still contain fossil water, locked in aquifers that supply wells in modern Libya, Chad and Sudan. Radar mapping reveals networks of channels that once carried monsoon rains thousands of kilometres across the desert. The Sahara, it turns out, is not a wasteland. It's a fossilised ecosystem. Every dune is a page from a wetter past. The African humid period reminds us that climate can give as quickly as it takes. For 3,000 years, its sustained civilizations were only beginning to understand. And when it ended, it didn't just reshape landscapes, it rewired human geography. The Sahara's desiccation isolated populations, redirected trade routes, and may have influenced the rise of new cultural centres farther south and east. It forced humanity to adapt once again, to become travellers of deserts instead of stewards of lakes. If we could stand in that vanished world now, we might not recognise it. The air would be heavy with humidity, the ground soft beneath tall grasses, the sky alive with birds. Crocodiles would slide through river channels. Children would play in the shallows of Lake Megachad, their laughter echoing across a basin that today is cracked and silent. The Green Sahara was not a myth. It was one of Earth's great seasonal experiments, a reminder that deserts, like empires, can bloom and die. The story we tell of humanity's origins often centres on fertile valleys and rivers we can still find on maps. But perhaps the truest cradle of civilization lies under dunes and dust, in places that remind us how temporary even paradise can be. Somewhere under the sands, the sediments still whisper of rain, of reeds, of footsteps on wet soil. A whole world once existed there, and then it didn't. Whether you're winding down for the night or trying to slow your mind after a long day, you're listening to Sleepless Homo. Tonight, we're in the moment when humans stopped trusting chance and began to trust themselves. For hundreds of thousands of years, food had been something found, gathered, hunted, stumbled upon. But around 10,000 years before the present, that changed. Someone, somewhere, had the idea that the future could be planted, and the story of civilization quietly began with a seed. The end of the Ice Age didn't just warm the world, it stabilized it. Seasons became predictable, rainfall patterns more regular, and with that predictability came opportunity. In a strip of land stretching from modern Syria to southeastern Turkey, along the Euphrates and into the Jordan Valley, humans began to notice something strange. The wild grains they had gathered for generations, barley, emmer and einkorn wheat, grew best in the disturbed soil near their camps. Where they spilled seed during harvest, new plants sprouted the next year. The landscape was already teaching them agriculture. They just had to listen. At sites like Muribit and Jericho, archaeologists have found the traces of that learning curve pressed into the earth itself. Charred grains of wild cereals, grinding stones slick with starch residue, storage pits lined with straw, all tiny pieces of a puzzle showing how gathering slowly became cultivation. The first step wasn't deliberate farming. It was noticing patterns. People began returning to the same spots where wild cereals grew thickest, cutting them with flint sickles, carrying them home in woven baskets. Each time they did, they unintentionally altered the gene pool. Grains that clung longer to their stalks survived harvesting. Seeds that fell too early were lost. Within a few centuries, humans had changed the biology of plants without meaning to. That's the quiet irony of domestication. It often begins by accident. The wheat that no longer shatters easily in the wind, the barley that ripens uniformly, the lentils with thinner seed coats. All these traits would have been invisible at first, but to hungry eyes they meant reliability. And reliability is the foundation of civilization. By around 9,500 years before the present, these experiments had taken root, literally. In the Tell of Jericho, one of the earliest known permanent settlements, layers of soil preserve not just stone tools but botanical fossils. Under a microscope, the differences between wild and cultivated grains become clear. Larger seeds, thicker husks, and uniform ripening. Archaeobotanists use these clues to reconstruct the first domesticated crops, tracing them back to the Fertile Crescent, where the combination of climate, topography, and human persistence aligned perfectly. It's easy to underestimate how radical this was. To grow your food is to gamble on time itself. You have to plan months ahead, to imagine a future self eating what your present self plants. It requires not just knowledge, but imagination. The people who took that leap weren't simply changing their diet. They were changing their relationship with uncertainty. Hunting and gathering had taught flexibility. Farming required faith. The domestication of animals followed close behind. In the hills of the northern Levant, bones of goats show subtle signs of management. The age profiles of herds, many young males, fewer older females, suggest selective culling. These were no longer wild herds hunted at random. They were controlled populations. Humans had begun to shape the reproduction of other species. The same logic that guided seeds now guided animals. Nurture what feeds you. Breed what behaves. Protect what provides. When archaeologists sift through the remains of these early communities, they find more than tools. They find evidence of patience. Grinding stones worn to hollows from years of use. Sickles polished by the silica of countless stalks. Traces of ash from controlled burns used to clear fields. This was labour that required memory. People no longer worked for today's meal, but for next season's. Time itself had become part of the toolkit. In this sense, agriculture was the first biotechnology. It was genetic engineering done by observation and repetition. Each harvest was an experiment, each seed a data point. Over generations, people learned which combinations of soil, rain, and seed produced the best yields. They learned that barley tolerated salt, that lentils fixed nitrogen in the soil, that certain weeds hinted at fertile ground. Their laboratories were fields, their archives were baskets of seed. But farming didn't replace foraging overnight. For centuries, the two ways of life coexisted. Some families still hunted gazelles or gathered nuts, while others tended plots nearby. This hybrid economy gave resilience during bad seasons. In a sense, domestication wasn't a single invention. It was a long negotiation between humans and the ecosystems that had once fed them freely. The archaeological record from Muribit captures that negotiation beautifully. Layers from around 10,000 years before the present show alternating phases. Periods of wild plant use followed by intervals of increased cultivation. The soil literally preserves the rhythm of trial and error. One season, more wild barley. Another, more domesticated. It wasn't a straight line toward farming. It was a feedback loop of observation and adaptation. As this experiment unfolded, the human body itself began to change. Bones from early agricultural communities show differences in muscle attachment and wear. Grinding grain for hours each day left marks on shoulders and knees. Diets shifted toward carbohydrates, leading to new dental patterns. Farming brought abundance, but also monotony. People were eating more, but less variety. The physical traces of that trade-off remain etched in skeletons across the Near East. And yet, the psychological impact may have been even deeper. For the first time, people had a tangible sense of ownership over the landscape. A plot of land wasn't just territory, it was memory made visible. Each seed carried the echo of the last harvest. Each field was a calendar, each season a story. The rhythm of nature became human rhythm. Plough, sow, wait, harvest, rest. In this new cycle, humanity found a strange kind of permanence, and also a new kind of dependence. Because to plant a field is to tie yourself to it. Once you've cleared land, tended crops and built storage, moving on becomes harder. The seeds root you as much as you root them. The mobility that had defined our species for hundreds of millennia began to fade. Settlements grew, populations increased, and with them came new social complexities, division of labour, cooperation, and inevitably conflict. But that story belongs later. For now, we are simply watching the first farmers bend over a field of green, realising that the earth could be persuaded to give more than it offered. The most striking thing about these early farmers is how localised their knowledge was. Wheat and barley emerged in the Levant. Rice would later appear in East Asia. Maize in the Americas, millet in Africa. Each domestication was independent, yet the principle was universal. Humans learning to read landscapes like scripts. Every region found its own vocabulary of survival. It's humbling to realise that the global web of agriculture we depend on today began as scattered experiments by small groups with flint tools and persistence. If you held one of those first grains of domesticated wheat in your hand, it would look ordinary, smaller than modern varieties, unevenly shaped. But inside it lies a genetic story of partnership. Wheat became dependent on humans to reproduce. Its seeds no longer dispersed efficiently on their own. The relationship was reciprocal. We fed it, it fed us. Over time, both species evolved together, a co-evolution written not in fossils but in flour and bread. What we're looking at here is the origin of design thinking, the moment when humanity began to shape nature consciously, not just respond to it. These early farmers might not have thought of themselves as innovators, but they were the first to tinker with the code of life. They selected, preserved, and modified living systems to fit their needs. The outcome wasn't just food, it was foresight. Today, archaeobotanists still study the charred seeds from Jericho, the pollen trapped in ancient sediments, the microfossils clinging to grinding stones. Each one tells us that agriculture wasn't an invention but a discovery, that we didn't conquer nature so much as learn its rhythms and join them. And maybe that's why the first fields feel so familiar, even across 10 millennia. They represent not just the beginning of farming, but the beginning of a relationship, a dialogue between human memory and biological time. So when did food stop being found and start being planned? Somewhere between chance and curiosity, somewhere between a dropped seed and a realization that it might grow. That was the moment we became the designers of our own survival. The first biotechnology wasn't a laboratory. It was a patch of wild grass and a mind that refused to leave it alone. Tonight, we're walking through the first cities that weren't quite cities, built by people who hadn't yet learned how to write or rule but somehow already knew how to build. Before empires, before temples, before metal, humans began shaping space itself. And the question is as old as the first wall. Did architecture begin as shelter, or as storytelling in stone? 10,000 years before the present, the experiment of permanence had already begun to change human life. Across the Fertile Crescent, small clusters of people, descendants of the first farmers and herders, were learning what it meant to live in one place for generations. They no longer followed herds or waited for wild grains to ripen in the hills. They were surrounded by domesticated plants and animals, by familiar rivers and predictable seasons. But with that stability came a new problem. Once you settle, you have to start managing not just nature, but people. And for that, you need something invisible yet powerful. A shared space. A place that holds memory and meaning even when no one is speaking. That idea, the architecture of belonging, may be what gave rise to the world's first monumental structures. Take Jericho, around 10,000 years before the present, one of the oldest continuously inhabited sites on Earth. When archaeologists first dug beneath its layers of history, they found something unexpected. At the base of the ancient mound, a massive stone tower over 8 meters high, built with an internal staircase and walls more than a meter thick. It wasn't a house, it wasn't a storage building, and it was far too large for one family or clan to build alone. The stones, rough, heavy limestone blocks, had been stacked with remarkable precision, laid in courses that still stand after 10 millennia. The Tower of Jericho is often called the first monument. Radiocarbon dates place its construction around 9,000 years before the present, long before kings or states existed. Whoever built it did so through cooperation alone. There are no signs of coercion or centralized control, no symbols of authority carved into its walls. It stands as proof that social organization can precede hierarchy. People came together not because they were ordered to, but because they wanted to make something larger than themselves. But what exactly was it for? Theories vary. Some suggest it was a defensive structure, built to protect the settlement from floodwaters or from outsiders. Others think it might have served as a granary, a watchtower, or even a timekeeper, a way to mark the setting sun during the solstice. Recent studies suggest the tower aligns with the shadow of the nearby Mount Kuruntul during midsummer sunsets, which could mean it acted as a kind of calendar in the stone. If so, Jericho's tower wasn't just architecture, it was astronomy, a physical reminder that the people of the early Holocene were already thinking in cosmic terms. Not far away, in the highlands of southeastern Anatolia, another community was experimenting with a different kind of public architecture. At Sayonu, near the upper Tigris River, archaeologists uncovered a plaza paved with polished limestone blocks, the earliest known example of planned communal flooring. Around it stood rectangular buildings with carefully laid stone foundations and plastered walls, some with red ochre floors so smooth they reflect light. One structure, dubbed the Grill Plan Building, contained a subfloor system of parallel stone slabs with air gaps in between, possibly for storage, ventilation, or ritual purposes. It is, in essence, the first engineered floor in human history. The sophistication of Sayunu's design suggests more than mere practicality. These people were shaping materials according to rules based on observation, trial, and shared memory. They were learning how to stabilize walls, redirect airflow, and create collective spaces where groups could meet and work. The site's long occupation sequence shows repeated rebuilding, structures taken down and reconstructed over centuries, each generation refining what the last had started. This wasn't architecture as accident, it was architecture as experiment. And then there were the homes themselves. Across the Near East, from Jericho to Abu Huraira to Murabit, early farmers began building circular or oval dwellings sunk slightly into the ground. Archaeologists call them pit houses. The design was ingenious. Partially subterranean walls provided insulation against both heat and cold, while lightweight roofs of reeds and mud offered ventilation. Each house had a central hearth, a reminder that even as societies changed, the human relationship with fire remained at the heart of daily life. Floors were plastered with lime, smoothed by hand, sometimes painted or repaired year after year. Beneath some of those floors, people buried their dead, a quiet merging of domestic space and ancestral memory. The consistent geometry of these early buildings reveals an emerging sense of measurement. Doorways align, hearths are centered, walls curve symmetrically. This wasn't random construction. It was design guided by shared principles. Imagine the coordination required. Dozens of people mixing lime plaster, carrying stones, shaping timber, maintaining right angles without tools of precision. Each structure was a communal effort, and every effort was a conversation. Architecture became a way of communicating ideas too large for language alone. What's striking about this period is how engineering flourished without hierarchy. There were no architects in the modern sense, no specialists, no rulers directing labour, and yet the results are both beautiful and complex. Jericho's walls, Sayunu's plaza, the pit dwellings of the Levant, all built through cooperation. It suggests that construction itself was a form of social cohesion. To build something lasting required trust, negotiation, and patience. The process may have been as important as the structure. Archaeologists studying the wear on tools from these sites find evidence of collective labour. Flint picks dulled by long use, pounding stones chipped and discarded in clusters, traces of lime dust coating the soil from mass plaster production. These are the fingerprints of teamwork. To produce enough lime plaster for a single house floor, tons of limestone had to be gathered, burned, and mixed with water, a process requiring fire hot enough to glow white, an organisation precise enough to synchronise dozens of tasks. It's no coincidence that around this time, social networks expanded. Communities that built together stayed together. What we're seeing here is the emergence of infrastructure as identity. A tower wasn't just a wall of stone, it was a declaration. We are here, and we built this. A plaza wasn't just a meeting space, it was proof that people could coordinate, imagine, and create stability. Architecture became a mirror of cooperation, a physical manifestation of social intelligence. And maybe that's why so much of early construction seems to exceed necessity. A simple roof would have sufficed for shelter. Yet people invested time in plastering, smoothing, decorating. They cared about how space felt. The acoustics of enclosed rooms, the glow of hearth light on polished lime, the coolness underfoot. All of it suggests that these early builders were creating environments that shaped emotion. They were discovering that architecture could influence mood and memory. If we strip away the centuries of stone and myth that followed, this was the true beginning of design. The first calculations of light and shadow, the first decisions about communal space, the first attempts to make permanence out of perishable material. Each layer of plaster, each fitted stone was an act of thought. It's tempting to see architecture as the child of civilization, but maybe it was the parent. Maybe it taught us how to organize, how to imagine together, how to live in our own creations. By 8,500 years before the present, these innovations had spread across the Fertile Crescent. Villages were expanding, plazas widening, and the first signs of urban planning appeared. Deliberate pathways between dwellings, shared storage areas, drainage channels. The leap from building for comfort to building for community was complete. Humans had learned how to design not just for survival but for society. Yet the most enduring mystery is not what they built, but why they built it all. Every culture needs shelter, but not every culture chooses to monumentalize it. The Tower of Jericho and the Plaza of Chayonu tell us that architecture began not only as protection from nature, but as a stage for imagination. These were spaces where people could see themselves reflected in structure, where labour turned into story and story into memory. And perhaps that's the secret buried in the first walls. Architecture didn't start with kings or blueprints. It started with the need to make meaning visible, to turn belonging into geometry, to build not just because we could, but because we couldn't stop ourselves from trying to leave a mark that outlasts us. The Tower of Jericho still stands, its stones weathered but defiant, the first human attempt to speak through structure. It's not just the oldest building, it's the first sentence ever written in stone. Alright, whether you're lying awake under soft rain or driving through darkness with your thoughts wandering toward deep time, you're listening to Sleepless Homo, and tonight we're diving into stories that survived the sea. Not in stone, not in DNA, but in words, told and retold until memory itself became topography. Across the planet, from the Arctic to the Amazon, from the Pacific Islands to the highlands of Anatolia, human beings kept telling the same kind of story. About water that rose too high, about lands that vanished, about a few who survived on hills, mountains, or boats. Are myths the memory of topography? When scientists began mapping the planet's post-glacial flood history, they were struck by how neatly those maps seemed to overlap with ancient storytelling. Between 10,000 and 6,000 years before the present, the world's coastlines transformed dramatically. Inland seas expanded, ice-dammed lakes burst, the oceans rose by tens of meters, swallowing tens of millions of square kilometers of land. For people living in that age, the ground itself was unstable. It shifted, vanished, and reappeared somewhere else. The shock of that experience would have been profound. Yet in many cases, the only trace of those floods we have left is not geological, but linguistic. Take the epic flood stories of Mesopotamia, written thousands of years later in cuneiform but echoing oral traditions far older. The Sumerians spoke of Ziusudra, a righteous man warned of a divine deluge who built a vessel to preserve life. The Babylonians retold it through Utnapishtim in the Epic of Gilgamesh, and later still it became the biblical tale of Noah. Beneath their cultural layers, these stories share something older than religion, the memory of rising water. Archaeologists have long debated whether a real event inspired them. One possibility lies in the flooding of the Persian Gulf basin around 8,000 years before the present, when a vast fertile plain was inundated by the advancing sea. Another candidate is the sudden refilling of the Black Sea, which some researchers argue produced catastrophic local floods remembered for millennia. But the Near East is only one part of the pattern. Half a world away, Australian Aboriginal oral traditions, some of the oldest continuous narratives on Earth, also describe the sea-swallowing ancestral lands. One story from the Yidinji people of northern Queensland tells of a time when the shoreline lay far beyond the present reefs, until the sea came in and drowned their hunting grounds. Geological surveys show that the region's coastal plain was indeed submerged about 7,000 years ago. Similar accounts exist from dozens of coastal groups across Australia, each aligning with specific topographical features now underwater. Researchers who've compared these myths to sea level models estimate that some oral traditions may preserve accurate environmental data more than 10,000 years old. In the Pacific, Polynesian and Micronesian peoples speak of floods that reshaped their islands, of ancestral canoes that found new land after the ocean rose. In India, the story of Manu, the man who survives a cosmic flood by following the advice of a speaking fish, appears in Vedic texts that may encode memories of ancient river floods during the late Pleistocene. In the Americas, Inuit traditions recall the breaking of ice barriers and the rush of new seas. Andean myths speak of mountains swallowing entire valleys of water. Among the Ojibwe, elders once told of a deluge that covered the earth except the tops of the highest trees, eerily consistent with glacial meltwater flooding in the Great Lakes Basin. The remarkable thing isn't that these stories exist, it's how detailed they often are. They describe specific coastlines, the colour of the water, the direction of retreat. Oral historians and geologists have begun to treat such narratives as complementary data, a kind of pre-literate geology. When multiple traditions converge geographically and thematically, they can highlight regions of significant environmental change. For example, the Haida and Tlingit peoples of the Pacific Northwest recount lands lost to the sea after the collapse of glaciers. Modern sediment cores from their territories show precisely timed marine transgressions in the same window, around 9,000 years before the present. This overlap raises a larger question about human cognition. Could oral cultures preserve geological events for thousands of years with meaningful accuracy? Studies of memory transmission in non-literate societies suggest yes under certain conditions. When a story is tied to ritual, song, and geography, it anchors itself in place. Each retelling refreshes the details, and because the landscape itself reinforces them, the mountain, the bay, the dry riverbed, they don't drift as easily as abstract myths. The environment acts as a mnemonic device. Story becomes map. In that sense, flood myths might be the world's oldest archive of sea level change. They don't describe global cataclysm so much as local experience. A village drowned, a shoreline gone, a new bay where there was none before. To a community dependent on coastal hunting or river irrigation, such changes would have been existential. For us, it's geology. For them, it was history. We often assume that ancient people used myth to explain what they couldn't understand, but perhaps it was also a way of preserving what they did understand, encoding memory into narrative so it could outlive those who witnessed it. When scientists reconstruct the paleo coastlines of the early Holocene and overlay them with flood legends, the result is less superstition than pattern recognition. Storytelling may have been humanity's first form of data storage, robust enough to survive through language drift, migration, and millennia of retelling. There's a humility in that realization. Today we record events in databases, believing digital permanence will outlast us. But the oral traditions of pre-literate people have already endured 10,000 years of change. Some of them might outlive the servers we build. The flood stories that cross generations are not warnings, they are resilience made audible. Each retelling was a rehearsal for survival, how to move to higher ground, what to take, who to trust. In some cases, those lessons may have saved lives when the waters rose again. When viewed this way, mythology and geology begin to merge into one field. The study of how Earth's surface and human memory shape each other. A flood is both an event and an emotion. The land drowns, but so does certainty, and the human response to make a story is an act of defiance against oblivion. That's why flood narratives persist even in regions where water has long since receded. The memory of vulnerability becomes a cultural fossil. For modern researchers, this opens a new kind of collaboration between disciplines. Geologists use cores and isotopes. Anthropologists use words and rhythms. When both point to the same horizon, the past becomes clearer. For instance, the oral histories of the Kwakwaka'wakw people on the coast of British Columbia describe a great tide that swept through their inlet and left shell middens buried beneath new soil. When archaeologists dug into the same sites, they found tsunami deposits consistent with an ancient landslide-triggered wave. The story and the sediment told the same truth. It's easy to see myth as fiction, but perhaps fiction is just a technology for preserving fact. The difference is that myth carries emotion alongside information, ensuring it is remembered. In that sense, the storytellers of 10,000 years ago were also archivists of climate history. They didn't need instruments, they had continuity. And maybe this is why the flood motif appears almost everywhere. It's not a coincidence, it's a human constant. We've always lived at the edge of change, where rivers shift, coasts erode, and weather forgets its patterns. The flood isn't just water, it's time moving faster than memory can follow. And to survive that, we told stories. Today, when we look at rising seas and melting ice, we are, once again, living inside the same kind of story. But we've forgotten how to translate emotion into myth. The people of the early Holocene didn't separate science and storytelling. Both were tools to remember that the earth moves beneath us. Every legend of water that came from the sky or swallowed the plains carries the same quiet wisdom, that permanence is an illusion, and that survival begins with remembering where the water once was. So maybe myths aren't metaphors at all. Maybe they're maps, emotional maps drawn by ancestors who wanted us to know what the ground beneath our feet can do. And as sea levels rise again, those old maps might not just describe the past, but the near future. We're following the people who stopped running from the water and started learning to shape it. For tens of thousands of years, floods had been the enemy. Rivers could give life, or erase it overnight. But somewhere around 9,500 years before the present, a few groups of humans did something extraordinary. They began to move the water first. Who controlled the flood instead of fearing it? The idea seems simple to us now, but it was revolutionary then. Water was no longer just something to drink or cross. It was a material that could be redirected, stored, slowed down, or made to flow where it normally wouldn't. The earliest traces of this idea don't come from mighty dams or royal inscriptions. They come from the quiet fingerprints of prehistory, small ditches, lined channels, and traces of silt that should not have been where they are. In the highlands of southeastern Anatolia, where rainfall was erratic even during the early Holocene, archaeologists have found remnants of stone-lined gullies near early Neolithic settlements, such as Sayonu and Nevelachori. At first, they were thought to be simple drainage features, but careful study revealed something subtler. Their slope and curvature were intentional. They captured runoff from seasonal rains and directed it toward fields or storage pits. These were not accidental erosion patterns, they were infrastructure. Humans had begun to edit hydrology. Further east, in the foothills of the Zagros Mountains, near sites like Jarmo and Ganj Dara, ancient terraces and shallow channels tell a similar story. The terrain here was difficult. Steep valleys, flash floods, dry summers. Yet the soil was rich and the streams abundant. To survive, early farmers learned to build low embankments that slowed water flow, allowing sediment and moisture to collect in basins. The technique, known today as contour bunding, may have been discovered through observation of how floodplains regenerated vegetation after storms. Copying the logic of the landscape, they began to coax fertility from the margins of chaos. Evidence for these early experiments comes from sediment cores, pollen analysis, and microtopography. Tools of modern archaeology that can read a landscape the way one reads a text. At Jarmo, alternating layers of silt and soil suggest controlled flooding, not natural deposition. At Sayonu, chemical traces of increased phosphate concentrations indicate irrigation runoff. These are faint clues, but when combined, they sketch a picture of intentional water management far earlier than once believed. Meanwhile, along the Proto-Indus Delta to the southeast, where the rivers of what would later become Pakistan met the sea, humans were developing their own relationship with water. The region was a shifting mosaic of wetlands, tidal creeks, and floodplains. Here, the first evidence of fish traps and tidal embankments appears. Woven reed barriers set across tidal channels, designed to catch fish as the tide receded. This was not agriculture, but it was engineering. To build a fish trap that works, one must know the rhythm of tides, the gradient of channels, the behaviour of species. These early coastal peoples turned hydrology into strategy. If you walked through these landscapes around 8,000 or 9,000 years before the present, you wouldn't have seen canals in the modern sense. You'd have seen ditches running like veins through soft earth, ponds reflecting the sky, stones stacked along a slope to redirect a stream. The work was done by hand, guided by memory, adjusted each season. Every trench was an experiment, every storm a test. And slowly, year after year, the knowledge accumulated. Water became a teacher. People learned that soil left damp for too long soured and turned white with salt. They learned that channels too steep eroded, too shallow stagnated. Trial and error became hydrological science long before that phrase existed. Archaeologists can even trace the improvement of design through time. Channels widening, slopes evening out, sediment traps added at intervals. What we see preserved in the dirt is evolution, not of species, but of ideas. One of the most fascinating finds comes from the site of Tel Es-Sawan in modern Iraq, where remnants of a canal system dating to around 7,500 years before the present suggest organised irrigation on a scale previously thought impossible for that period. The canals were modest, less than a metre wide, but their orientation relative to the Tigris floodplain implies planning. The builders understood gradients and water flow. They weren't just channeling water, they were channeling knowledge. To understand how monumental this was, imagine living in a world where rain determined life and death. Then imagine realising that you could cheat the sky. You could extend the growing season, recover after a dry year, and feed more people with the same land. The manipulation of water was the first true act of environmental design, a declaration that humans were no longer passengers of the climate, but participants in it. And yet what's remarkable is how these early water systems show restraint. They didn't conquer the landscape, they worked with it. Ditches followed the natural contours of the terrain. Seasonal floods were not blocked but harnessed. When rivers rose, they spread nutrient-rich silt across the fields, renewing fertility. When they fell, farmers dug shallow trenches to retain the moisture. It was adaptive, not extractive, a balance we would later forget. Even hunter-gatherer groups participated in this quiet revolution. Along rivers in what is now Jordan and Syria, archaeologists have found the remains of stone weirs, low walls built across small streams to slow water and trap fish. Some of these date to nearly 10,000 years before the present, overlapping with the earliest farming sites. The distinction between forager and farmer was blurring. Managing water blurred it further. The engineering intelligence of these communities is easy to underestimate because it left no monuments, no inscriptions, no obvious legacy. But the cognitive leap was immense. To plan a channel, you must visualize water that isn't there yet. You must predict a movement and imagine outcomes. That act, thinking ahead in 3 dimensions, modelling the unseen, was a kind of proto-science. It required cooperation, measurement, and memory. It was a social technology disguised as mud work. As the centuries passed, these techniques spread. Along the eastern Mediterranean coasts, rain-fed terraces multiplied. In the valleys of Iran, early Qanat-like tunnels began to appear, horizontal shafts that captured groundwater and brought it gently to the surface. The principle of hydraulic gradient, something modern engineers still calculate, was being applied by people with nothing but stone tools and intuition. Water systems also reshaped communities. Managing a canal required agreement. When to open, when to close, how to divide flow. It introduced the concept of scheduling, of shared responsibility. The earliest evidence of communal storage pits and cooperative maintenance may have come from irrigation itself. Water demanded organisation, but not necessarily hierarchy. For a while, at least, it was a shared project, a democratic technology. In recent decades, scientists have begun to model the hydrological changes of the early Holocene using satellite data and paleoclimate records. They've found that regional rainfall fluctuations align strikingly with archaeological innovation. In years of drought, canal networks expanded. In years of abundance, they contracted. This suggests a direct link between stress and creativity. The more unpredictable the water, the more humans learned to predict it. What these first engineers achieved wasn't domination over nature, but dialogue with it. They didn't build to control chaos, they built to understand it. Every channel carved into earth was also a record of observation, where the soil cracked, where the reeds grew tallest, where floods deposited the best silt. The wisdom was empirical, iterative, and collective, long before words like science existed. When modern hydrologists study these ancient sites, they find a sophistication that still surprises them. Hydraulic modelling of early Anatolian channels shows optimal flow velocities, fast enough to move water, slow enough to prevent erosion. This balance requires precise slope calculation, something we once assumed was beyond early farmers. But as one researcher noted, they didn't need equations, they had generations of trial and memory. If we step back and look at the pattern, we see something profound. The first monuments of humanity were not made of stone or fire, they were made of water. Invisible architectures of flow and time, canals, ponds and fish traps were our earliest experiments in control and cooperation. They changed not just landscapes, but minds. To guide water was to think like the earth itself. By 7,500 years before the present, those who once feared the flood had become its partners. Across Anatolia, the Zagros, and the Proto-Indus, societies had learned to stabilize their own environments through hydrology. They built nothing eternal, but everything essential. Their systems were biodegradable, vanishing with each generation, leaving behind only soil chemistry and the faint ghosts of channels. And yet, from those channels flowed the civilizations that would later define history. The story of humanity's relationship with water often begins with cities and empires. But the truth runs deeper, into the mud of prehistory. The first engineers were anonymous, their tools simple, their goals humble. But they were already solving the oldest problem, how to survive change without worshipping it. And maybe that's the lesson they left us. We spend our lives trying to stop the floods of time, to build walls against uncertainty. But those early humans knew something wiser. You don't stop the river. You learn to move with it, to shape its edges just enough to live. Tonight, we're not chasing bones or buildings, but something less visible and even older, the sound of thought itself. Between 9,500 and 7,500 years before the present, humans began leaving behind strange objects that spoke without words, tokens, flutes, stones marked with patterns. Fossils not of bodies, but of minds. Can sound fossils tell us what language felt like? When archaeologists dig through the layers of the early Neolithic world, they sometimes find things that don't fit cleanly into the category of tool or ornament. Smooth pebbles etched with lines, lumps of fired clay shaped into cones, spheres or discs. They're too small to be practical, too standardized to be random. For decades, these artifacts puzzled researchers, until they began to be studied as a system. They are now known as Neolithic tokens, and they may represent one of humanity's earliest attempts to record and communicate information outside the human body. At sites across the Fertile Crescent, from Ganj Dareh and Tepe Asyab in the Zagros Mountains to Tel Maribit and Çatalhöyük farther west, archaeologists have recovered thousands of these tiny clay pieces. Some are marked with hatchings or dots, others are left plain. Their shapes vary but recur predictably: spheres, cones, tetrahedrons, cylinders. When analysed in large collections, patterns emerge. Certain shapes appear consistently alongside evidence of specific resources: grains, livestock, textiles. In other words, they may have been a counting system. If this interpretation is correct, these small clay figures were the first step toward abstraction, the transformation of experience into symbol. A cone might mean a measure of barley. A sphere might mean a jar of oil. To hold one in your hand was to hold a thought made physical. The invention of symbolic tokens marks the moment when human memory began to externalize. Instead of remembering everything, people could represent it. Instead of relying only on speech, they could anchor speech in matter. The leap seems small, but cognitively it's enormous. It's one thing to trade food, it's another to represent it by shape. These tokens show that the human mind was beginning to model relationships between quantity and object, between material and meaning. The fact that they were made in durable clay suggests something even deeper: the desire to make memory last longer than sound. Meanwhile, another kind of artifact from the same millennia offers a more literal echo of communication: the first known musical instruments built for tone rather than noise. Bone flutes from sites such as Hasla in Anatolia and Jiahu in China, dating to roughly the same window of time, reveal a universality of experimentation with sound. The most famous examples, made from the wing bones of large birds, still play notes within the modern pentatonic scale. Whether or not they were used for music as we understand it, they demonstrate something unmistakable. Humans had begun to shape sound deliberately, carving rhythm and tone into the air itself. Imagine the scene. A group gathered at dusk, someone lifting a hollow bone to their lips, a tone rising through the silence. Thin, trembling, unlike anything natural. For the first time, sound detached from its source. A human breath could now echo like wind through reeds, but controlled, repeated, shared. These instruments are the earliest evidence of acoustic imagination, the idea that sound could carry meaning or emotion beyond immediate speech. It's tempting to divide these developments, tokens for numbers, flutes for music, but perhaps they were branches of the same root. Both represent the externalization of thought, the turning of invisible patterns into physical form. In both cases, humans were learning to shape symbols that could travel through time, one in clay, one in air. And maybe that's the lesson they left us. We spend our lives trying to stop the floods of time, to build walls against uncertainty. But those early humans knew something wiser. You don't stop the river. You learn to move with it, to shape its edges just enough to live. Even more intriguingly, some early Neolithic sites have yielded small clusters of rounded pebbles, marked with incisions or pigment streaks. At Ain Ghazal in modern Jordan and Asikli Hoyuk in Turkey, archaeologists have found stones arranged in ways that suggest counting or tallying systems. In some cases, the marks correspond to groupings of 10 or 5. They may have been used for keeping track of livestock or harvest yields, functioning as portable records, but their smooth wear and careful shaping hint at something beyond mere accounting. They might also have been mnemonic devices, tools to prompt storytelling or teaching, a physical rhythm for the spoken word. That connection between sound, a symbol, and rhythm is at the core of cognitive archaeology, the study of how the human mind itself leaves a trace in the archaeological record. Around this time, as settlements grew and cooperation became essential, communication needed new dimensions. Words alone could not organize hundreds of people planting, harvesting, trading, and storing food. Systems of reference, numbers, signals, gestures, evolved alongside the physical technologies of society. The artifacts of this period show language becoming architecture, thought acquiring scaffolding. One of the most striking finds from the early Holocene comes from Çatalhöyük, where a cache of clay balls was discovered near a storage area. Each had a different weight and size, as though used for measuring or counting grain. When one of them was cut open experimentally, it revealed smaller tokens sealed inside, perhaps representing specific quantities or categories. In that moment, abstraction had become layered, the clay container of clay ideas, a metaphor for thought itself. Parallel discoveries suggest that these systems were widespread, not isolated inventions. Across the Near East, archaeologists have traced the evolution of clay tokens over several millennia. Their shapes grow more diverse, their markings more complex, suggesting that over generations, communities expanded their symbolic vocabulary. This was not yet writing, there was no syntax, no grammar, but it was something close to it, the encoding of social reality into repeatable, recognizable forms. Sound, too, was evolving in similar ways. Musical flutes, bone whistles, and percussive instruments appear in increasing frequency across Neolithic contexts. Some show wear patterns consistent with repeated use. Others are found buried with individuals, suggesting ritual significance. Perhaps sound was already tied to memory, to ceremonies marking seasons, births, or harvests. The tones might have carried across open valleys, calling people together or sending signals between settlements. To a world newly connected by rivers, irrigation, and trade, sound was the fastest messenger. The deep link between language and rhythm might also trace back to this period. Speech itself has musical qualities: pitch, tone, cadence. As humans began crafting instruments, they may have become more aware of those qualities. The soundscape of daily life changed. Fields of wheat rustling in irrigation channels, stone tools tapping against grain, voices echoing in enclosed dwellings. All of it would have reinforced the sense that pattern could create meaning. In that sense, early Neolithic sound was not entertainment. It was an extension of intelligence. Even the choice of materials carries symbolic weight. Clay and bone, one from the earth, one from the body, both capable of holding shape, both easily broken. To make sound or symbol from them was to turn impermanence into memory. The clay token outlasted its maker. The bone flute carried the breath of someone long gone. Each artifact, in its own way, is a fossil of cognition, a record of humans beginning to think beyond their lifespan. Modern researchers studying these objects often emphasize how they blur the line between the practical and the poetic. A token may have represented a measure of grain, but it also represented trust. A flute might have been used to herd animals or to mark ritual time, but it also embodied emotion. In both, we see the earliest emergence of the dual mind, the pragmatic and the symbolic coexisting. What's beautiful about this phase of history is how quiet it is. There are no monumental inscriptions, no grand declarations, just small things: smooth clay, hollow bone, whispering of a revolution in thought. The first accountants and the first musicians may have lived side by side, both working on the same problem: how to make meaning travel. When you hold one of those flutes today, excavated and cleaned, it's hard not to imagine the sound. Scientists who've reproduced them describe the tone as hauntingly human, somewhere between bird call and breath. It vibrates in the same range as speech. Maybe that's why it feels so intimate. The air that once carried those notes is gone, but the shape that made them remains. It's as if thought itself left an instrument behind. And when you look at those tokens, tiny, unassuming, massed in handfuls from ancient floors, you realize that they too were instruments, but of memory instead of sound. Each one a syllable in the first great conversation between mind and matter. Can sound fossils tell us what language felt like? Maybe not directly, but they remind us that communication was once an act of creation, not routine. Every word spoken then carried the weight of invention. Every symbol carved into clay was an experiment in permanence. What we find in these artifacts isn't language as we know it. It's the scaffolding of thought, the first time a human mind reached beyond its voice and found a way to stay heard. Now we're following the footsteps of an animal that decided to follow us back. Long before cities or farms, before pottery or writing, humans made an alliance that would outlast ice, famine, and time itself. It wasn't planned, and it wasn't one-sided. Somewhere around 12 to 9,000 years before the present, a species of wolf began to evolve beside us, not through conquest, but through empathy. The question is still astonishing in its simplicity. Why did the first domesticated animal choose us back? By the end of the last ice age, humans and wolves occupied the same ecological niche. Both were apex social hunters, cooperative, strategic, wide-ranging. Both tracked herds across tundra and forest, used communication to coordinate, and relied on strong bonds within their groups. They were competitors, yes, but also reflections of each other. The partnership that would eventually form between them began not with taming, but with overlap. Archaeologists studying sites from Siberia to Central Europe have found traces of this proximity. Wolf and human bones often lie side by side in campsites dating to 12 or 11,000 years before the present. Sometimes they bear the same butchery marks suggesting shared prey. At other times, wolf remains show no signs of processing, implying coexistence rather than hunting. In one remarkable case, at Bonn Oberkassel in Germany, the burial of a young man and woman dating to roughly 14,000 years ago included a canine carefully placed beside them, dusted with red ochre. Its jawline and teeth show mixed traits, part wolf, part dog. It may be one of the earliest known companions rather than adversaries. Genetic studies suggest that the divergence between wolves, and the first domestic dogs happened sometime between 20 and 15,000 years before the present, but it's during the period after the Ice Age, between 12 and 9,000 years ago, that the relationship became permanent. By then, climate change was transforming everything. Glaciers retreated, forests spread, and megafauna declined. For both species, old hunting strategies stopped working. Cooperation offered a new path to survival. The earliest phase of this partnership likely began with what biologists call self-domestication. Some wolves, those less fearful and more tolerant of humans, began scavenging near human camps. They learned that proximity meant access to leftovers, bones, hides, scraps of fat. Over generations, these bold individuals thrived, passing on temperaments better suited to coexistence. Humans, for their part, tolerated these camp followers because they provided an unexpected service, warning of predators and strangers, cleaning refuse, and perhaps helping with the hunt. The result wasn't a trained pet, but a mutual adaptation. Both species were changing each other. You can imagine it. A frozen plain, a small band of humans clustered around a fire, and at the edge of the light, a pair of eyes watching, unblinking. The humans drop bones into the snow. The wolf doesn't attack. It waits. Gradually the distance closes. Fear softens into understanding. Every night the wolves come closer until one stays. Over generations, natural selection and human tolerance shaped these wolves into something new. Their skulls became smaller, their jaws shorter, their teeth less suited for crushing bone, and more for eating softer food. Their ears and tails began to droop, their coat patterns diversified. These were the first dogs, animals who had crossed an invisible line between wildness and trust. What makes this story remarkable is that it appears to have happened more than once. Genetic evidence points to at least two separate domestication events, one in Eurasia's west and one in its east, later merging as humans migrated and exchanged animals. That means the relationship wasn't an accident of geography, it was a natural convergence. Wherever humans and wolves met, the same logic unfolded. But this wasn't just a practical alliance. Something deeper was happening. Neurobiological studies on modern dogs show that when they gaze into human eyes, both species experience a surge of oxytocin, the same hormone that bonds parents and infants. This chemical empathy may have its roots in those early millennia of cooperation. Wolves capable of reading human cues and emotions would have had a survival advantage, and humans, in turn, may have been wired to respond to the animal's trust. What began as mutual convenience evolved into mutual recognition. Archaeological traces of this bond are subtle but powerful. Dog burials from sites like Ain Malahar in the Levant, dating to around 12,000 years ago, show animals interred with care, sometimes alongside humans, sometimes alone with grave goods. In one case, a woman was buried with her hand resting on a puppy's body. These were not tools or livestock, they were companions. Their inclusion in human ritual marks a turning point in cognition, the ability to form enduring emotional attachments across species. That emotional intelligence may have reshaped us both. Dogs adapted to our communication style, learning to interpret pointing gestures, vocal tones, and facial expressions. Humans, in turn, adapted to theirs, reading tail movements, postures, and barks. Language may not have been shared, but understanding was. It's no exaggeration to say that the first interspecies conversation began here, in silence, with eye contact and patience. This coevolution went beyond behaviour. Geneticists have found that both species experienced changes in similar gene pathways related to social bonding and stress regulation. Some of the same neural systems that make dogs gentle toward humans also appear in the domestication of ourselves, what scientists call self-domestication in Homo sapiens, reduced aggression, increased cooperation, extended juvenile traits. In that sense, our partnership with dogs may have been part of a larger evolutionary pattern, a feedback loop of empathy. Ecologically, the alliance was brilliant. Dogs expanded human sensory range. Their hearing and smell extended our perception into the dark and the wind. In hunting, they became extensions of our senses, able to locate prey or track wounded animals over kilometres. In return, humans provided stability, predictable food, protection, and warmth. Together, we formed what some ecologists call a super-predator pair. two species acting as one. By the mid-Holocene, as climates warmed and ecosystems stabilised, dogs had spread with humans across continents, from Siberian mammoth hunters to Levantine foragers to North American migrants crossing the Bering Land Bridge. Wherever people went, paw prints followed. In every region they adapted: thick-coated northern dogs, slender desert runners, compact marshland companions. The diversity we see today began with those early experiments in coexistence. But beyond the biology and the archaeology, there's something harder to quantify: the emotional transformation that must have occurred. To live alongside an animal that doesn't speak your language but understands your intent is to see yourself reflected in something not human. It may have taught us empathy in a new key, one not limited to our own kind. The ability to project feeling, to sense loyalty, to read body language beyond our species may have deepened the emotional intelligence that later underpinned cooperation among humans themselves. There's a quiet irony in this story. We often imagine domestication as a form of control, humans bending nature to our will. But in the case of dogs, the opposite might be true. They domesticated us as much as we domesticated them. They changed our sleep cycles, our hunting rhythms, even our social rituals. They shaped our evolution not through force, but through companionship. If you look at skeletal remains of humans and dogs from this period, you can sometimes see shared pathologies, healed injuries that suggest mutual care. A dog with a broken leg that had mended could not have survived without help. A human buried with a dog implies shared burial practice, shared emotion. These are the fossils of compassion. The partnership also had its own form of language. Not words, but timing, movement, tone. Studies on modern hunter-gatherer groups that still use dogs in cooperative hunting show a constant exchange of microsignals, hand motions, glances, shifts in breathing, that both species understand instinctively. This coordination likely emerged in prehistory and has persisted ever since. When you think about it, the dog-human alliance marks one of the great inflection points in the history of life. Two separate species, each intelligent in their own right, found a way to merge behaviourally, emotionally, and even genetically. Together they crossed the boundary between wild and domestic, predator and partner. And maybe that's why the first domesticated animal wasn't a herbivore or a prey species, but another hunter, an equal. Dogs didn't enter our world as servants. They entered as allies. They helped us survive, yes, but they also helped us understand what survival meant, that strength comes not from solitude, but from trust. 12,000 years later, that alliance still holds. Every modern dog, from Arctic sledhound to sleeping lap companion, carries in its DNA the memory of that Ice Age pact. When it looks at us with those familiar, unreadable eyes, it's reenacting the oldest friendship on Earth. And maybe that's what makes it sacred. Not because we shaped them, but because, once upon a time, they decided to stay. Now we're stepping into the warmth of a world that began to hold its fire still. Around 11 to 9,000 years before the present, something remarkable happened. Humans stopped walking away from the flame. They began to build around it. The hearth moved indoors. It was no longer a moment, it was a room. And with that, a subtle miracle began. The control of warmth started to control time itself. For hundreds of thousands of years, fire had been a visitor, something kindled, used, and abandoned. It belonged to the outside, to caves, to camps, to transient shelters. But when the last ice age loosened its grip, humans began to stay. The earth grew wetter, forests thicker, and winters more survivable. Settlements like Jericho, Muiribit, and Çatalhöyük appeared, and with them came something more permanent than a campfire. Built hearths, lined ovens, and floors hardened with lime plaster that radiated captured heat. Fire stopped being an event and became infrastructure. To understand how revolutionary that was, imagine what it meant for daily rhythm. Before the indoor hearth, light and warmth followed the sun. When night fell, life slowed. When storms came, the cold dictated rest. But a contained fire extended the day. It allowed food to be cooked without smoke choking the lungs, light to linger after dusk, work to continue inside. For the first time, humans could decide when the day ended. The hearth quietly began to bend the human perception of time. Archaeologists have traced the evolution of these domestic fires through layers of ash and architecture. At sites in the Levant, like Ain Ghazal and Beida, circular dwellings contained central hearths framed by clay rings or stone slabs, their positions fixed generation after generation. The floor beneath them hardened with repeated heating. Thin black lenses of soot interleaved with white plaster, each one a fossilized evening. These are the first calendars of habitation, marked not by stars but by warmth. In Anatolia, at Sayonu, and later at Çatalhöyük, fire technology advanced even further. Clay-lined ovens, tanners, appeared, shaped like inverted jars with openings at the top. They held heat for hours after the flames went out, turning scarce fuel into slow, even warmth. Some were used for baking grain or drying fruit, others perhaps for firing lime plaster. The introduction of lime was itself a leap of controlled chemistry. Heating limestone to over 800 degrees produced quicklime, which when mixed with water hardened into a durable surface. This was fire transmuted into architecture. People were no longer just keeping warm, they were engineering permanence. The presence of indoor fire changed everything about the human home. Walls darkened from soot, ceilings grew warm, and surfaces softened with smoke-polished residue. The air inside was no longer neutral. It had a smell, a texture, a memory. People began to organize space around the flame, sleeping closer in winter, storing fuel in corners, arranging tools within reach of the light. The hearth became the gravitational center of domestic life, a proto-clock marking cycles of activity, morning rekindling, midday cooking, evening storytelling. Time was now measured in embers, and with routine came new forms of attention. Fire required care. Too much fuel, and the smoke suffocated. Too little, and the coals died. Tending a fire became a ritual of mindfulness, an early discipline of observation and adjustment. Archaeologists studying charred remains from early Neolithic sites have even found evidence of mixed fuels, combinations of wood, dung and reeds chosen to balance temperature and duration. Each choice implies experimentation, memory and foresight. These were not random burns, they were recipes for stability. Fire also brought new soundscapes. Indoors, the crackle of wood became constant, blending with human voices and the quiet percussion of work. The steady glow of embers allowed for activities once limited to daylight, grinding grain, repairing tools, weaving plant fibres. Some anthropologists argue that the shared time around the hearth fostered new forms of communication, storytelling, and social bonding. When movement slowed, imagination had space to expand. The flicker of firelight became the first screen, the background to reflection, myth, and collective memory. Even sleep changed. Before permanent hearths, humans likely followed a segmented pattern, shorter bursts of rest between tending outdoor fires. With steady indoor warmth, sleep could extend, becoming deeper and more synchronized within households. Fire stabilized circadian rhythm long before clocks. It tamed the night not by removing it, but by softening its edge. In many early dwellings, the hearth also served a symbolic role. In Jericho, burials beneath house floors were sometimes placed near hearths, linking the dead to the continuity of warmth. The flame was not just practical, it was ancestral. At Çatalhöyük, wall paintings and clay reliefs near hearths suggest that domestic fire was connected to ritual or identity. Some archaeologists interpret the oven as a metaphorical womb, a source of both heat and transformation. To bake bread or plaster was to recreate creation itself, turning raw matter into sustenance or structure through controlled combustion. Yet this mastery came with consequences. Living with fire indoors changed human biology. Constant exposure to smoke may have influenced respiratory adaptations and even immune responses. Charcoal layers in ancient lungs, preserved in skeletons, tell a story of endurance. The price of comfort was inhaled, but the benefits outweighed the cost. The controlled hearth extended survival in cold seasons, reduced dependence on unpredictable sunlight, and allowed settlements to endure through environmental fluctuation. From a wider perspective, the indoor fire represents one of the earliest examples of energy storage. a principle that would later define civilization. A hearth stores heat after the flame is gone, a delayed release of energy that humans learn to manage. In that sense, every modern furnace, battery or server farm is a descendant of the Neolithic fire pit. The pattern began with coals glowing through the night, waiting to be stirred back to life. There's also an emotional truth embedded in this technological shift. Fire inside the home became a companion presence, alive but contained, responsive yet dependable. People began to assign it personality, to speak to it, to feed it as though it had appetite. This early animism may have shaped spiritual traditions that linked fire to vitality, transformation, and protection. The hearth was both guardian and witness. In cognitive terms, the act of maintaining fire indoors rewired attention. It required planning over hours and days rather than minutes. It made the future tangible. If you tended the flame now, tomorrow would still be warm. That kind of deferred thinking, the patience of tending rather than consuming, might have reinforced the mental architecture that later supported agriculture and long-term cooperation. Archaeologists reading the stratigraphy of early houses see this continuity written in ash. Each occupation layer contains a hearth rebuilt on the same spot, sometimes directly over the old one, as if the location itself carried inheritance. When a family moved or died, the next generation rekindled fire in the same place. Over centuries, those layers form mounds, tells, rising from the plains, each metre of sediment the thickness of a life. Beneath the dust of ancient towns lies not chaos but order, thousands of small decisions to keep warmth at the centre. And perhaps that's what made it possible for humans to imagine permanence at all. Before fixed fire, existence was cyclical, movement dictated by migration, weather and daylight. With the hearth, linear time emerged. Yesterday's coals became tomorrow's flame. The rhythm of life began to include continuity. Fire indoors didn't just heat the body, it heated memory. When we look back now, it's easy to overlook the scale of that transformation. No monument marks the moment when flame moved inside. No inscription celebrates the first person who decided to build a wall around a spark. Yet in that gesture lies the foundation of civilization. The decision to enclose warmth, to keep change within reach. It was the first architecture of comfort and the quiet beginning of human domesticity. Even now, thousands of years later, our sense of safety is still linked to that image. A room lit from within, the faint hum of stored heat, the calm certainty that something is burning gently nearby. We've built cities and satellites, but the feeling of home remains elemental. Glow against darkness, warmth against wind, fire that waited indoors. All right. Whether you're in bed, staring at the ceiling, walking home at night, or just letting the world slow down, you're listening to Sleepless Homo. Tonight we're turning east, away from the familiar floodplains of the Fertile Crescent and the sunlit ruins of the Mediterranean, toward the edges of a map that disappeared long before we ever drew it. Between 10,000 and 7,000 years before the present, the world's tropics hid one of the largest drowned landscapes on Earth, a place where early humans built, traded and adapted as the sea rose around them. The Sunda Shelf, the South China Sea Basin, and the coasts of ancient Japan once formed vast plains of forests and rivers. Today, they are gone. So, what traces hide beneath the tropical shelf seas? If we could drain the oceans for a moment and see the Earth as it looked 10,000 years ago, Southeast Asia would look almost unrecognizable. The modern islands of Indonesia, Borneo, Java and Sumatra were once part of a single subcontinent, Sundaland. To the north, the shallow South China Sea was a vast lowland plain, linking Vietnam to Borneo. Farther east, the Philippine archipelago and Japanese islands were double in size, their coastal shelves wide and green. This drowned world connected populations across Asia, creating a web of migration and exchange that lasted thousands of years. Archaeologists call it Asia's lost heartland, but it's not mythical. We can map its rivers, trace its deltas, and even name its vanished lakes. Satellite bathymetry shows the ghosts of channels that once carried monsoon rains across a tropical savanna the size of Europe. During the Ice Age, when sea levels were lower by up to 120 metres, this plain was home to dense forests, grasslands and rivers teeming with life. as the ice melted after about 10,000 years before the present, the sea began to rise, flooding that entire continent over just a few thousand years, a geological blink. The people living there didn't have a written record, but they left clues. From coastal caves in Borneo to river terraces in Sumatra and the Malay Peninsula, stone tools, shell middens and charcoal layers show continuous habitation, stretching back tens of thousands of years. The toolkit of these people, flakes, blades and grindstones, changes subtly through time, showing adaptation rather than replacement. They were not simply foragers trapped by rising seas, they were innovators adjusting to an unstable world. One of the key discoveries that changed our understanding of this region came from Naya Cave in Borneo, where archaeologists found the remains of a young woman dating to around 11,000 years ago, known as the Deep Skull. Her features show continuity with later Southeast Asian populations, suggesting that as the world flooded, people didn't vanish. They moved upward and inward, retreating to the mountains and coast that remained above water. Her bones, preserved under layers of guano and ash, represent a bridge between two worlds, the Ice Age interior and the coastal adaptation that followed. In the flooded plains south of modern Vietnam, sonar surveys have revealed the outlines of ancient river valleys, meandering channels now buried under sediment. These are the drowned arteries of the Mekong and Chao Phraya rivers. Along their former banks, archaeologists have begun to recover traces of human activity. Concentrations of stone flakes, charcoal patches and shell debris, all consistent with prehistoric habitation. Each fragment reminds us that what we call islands today were once connected by land bridges crossed by herds, hunters, and families who could walk from mainland Asia to Java without seeing open ocean. Farther north, along what is now the coast of China, the South China Sea once formed an enormous fertile basin with lakes and inland deltas. Recent marine cores taken from its seabed contain pollen from freshwater vegetation and traces of charcoal from ancient fires, signals of human presence long before the ocean claimed it. These findings suggest that early agricultural experiments, once thought unique to the Middle East, may have had Asian counterparts hidden beneath these tropical seas. The oldest rice phytoliths, microscopic silica remains from plants, have been found in regions adjacent to this drowned world, hinting that some of the earliest rice cultivation could have begun not in inland China, but along its now submerged coastal plains. Meanwhile, to the northeast, the Jomon culture of ancient Japan was developing a parallel form of complexity. As early as 9,000 years before the present, the Jomon people were building pit dwellings, creating elaborate pottery, and exploiting rich coastal ecosystems of fish, shellfish, and sea mammals. They were among the first societies in the world to live semi-sedentary lives while still foraging. At sites like Torihama and Sanai Maruyama, archaeologists have uncovered thick layers of shell and bone, decorated pottery fragments, and polished stone tools, suggesting that innovation was happening simultaneously, independent of the agricultural revolutions unfolding elsewhere. The rising sea reshaped their world as well. Japan's coastlines moved inward by tens of kilometres. Villages that once stood on river mouths ended up underwater. Some researchers argue that the persistence of shell middens high on later hillsides reflects communities following the retreating shoreline, generation after generation, maintaining their traditions even as the geography dissolved beneath their feet. If we look at all these regions together, from the Sunda Shelf to the Yomon coast, a clear pattern emerges. Asia's forgotten edges were not isolated or primitive. They were active, adaptive, and inventive. The floods that erased their landscapes also preserved their legacy beneath layers of sediment. In some cases, underwater archaeology has begun to recover that legacy directly. Off the coast of Okinawa, divers have explored submerged terraces and rock formations that, while natural, show evidence of tool use nearby. Near the coast of Thailand, sonar mapping has revealed potential paleo-shoreline settlements buried under sand and coral. Each discovery adds to a growing realization. The story of human innovation after the Ice Age is not just about the Middle East or Europe. It's also about the tropics that drowned quietly beneath the sea. For decades, this region was left out of prehistory because its evidence was inaccessible. But now, with sonar imaging, underwater excavation, and sediment analysis, archaeologists are beginning to write it back in. One of the most striking findings comes from the southern coast of China, near the Pearl River Delta. There, ancient peat layers beneath marine sediment contain pollen from tropical hardwoods and traces of cultivated plants, dating to between 8 and 7,000 years ago. It suggests people were already manipulating vegetation, perhaps clearing patches or planting useful species, on land that is now far below the waves. In some ways, the story of these drowned edges mirrors the story of Doggerland in Europe, but the scale here is far larger, the biodiversity richer, and the timeline longer. Southeast Asia's shelf seas hold not just the memory of landscapes, but of entire ecosystems, mangroves, rivers, forests, and human lifeways that adapted to them. As the water rose, people did not vanish. They became islanders, traders, and sailors. By 7,000 years before the present, they were navigating between coasts carrying obsidian, shells, and seeds. The flooded plains may have pushed them outward, creating the maritime networks that would later link the Pacific. It's tempting to imagine that these people, watching the water creep up their familiar valleys, told stories about what was being lost. Perhaps they remembered where the old rivers ran or where ancestors once lived, passing those memories down through generations. Some researchers even suggest that certain regional flood myths, from island Southeast Asia to the Pacific, may preserve distant memories of these drowned lands. Whether myth or data, they remind us that the sea's silence is not the same as forgetting. What makes the story of Asia's forgotten edges so powerful is how it rewrites the geography of innovation. Civilization did not radiate outward from a single cradle. It flickered to life in many places at once, in cold valleys, in deserts, and here, in the humid margins of a world that would soon vanish beneath the waves. These people built fires in limestone caves, shaped tools from river stones, and gathered fruits and shellfish from tidal flats. They learned to live with water as both threat and teacher. Today, oceanographers mapping the Sunda Shelf speak of its rivers as ghost waters. They run across the seafloor like veins of memory, carrying sediment that once nourished forests and people. Each sonar sweep reveals something human. The geometry of a floodplain, the trace of a terrace, the suggestion of a camp that no longer exists. It's an eerie kind of archaeology, one where the evidence lies just out of reach, waiting beneath layers of coral and silt. And maybe that's fitting. These were people who lived on thresholds, between land and sea, between the Ice Age and the modern world. Their story reminds us that the past isn't fixed on dry ground. Most of it, quite literally, has already slipped beneath the surface. When we look across the calm waters of the South China Sea or the Java Sea today, we're staring down at the ruins of another continent, one that never had a chance to be remembered. So much of history depends on what didn't drown. But the forgotten edges of Asia tell us something else, that human brilliance was never confined to one region or climate. It flourished anywhere we could light a fire, build a raft, or adapt to change. These submerged plains may never be fully excavated, but their legacy survives in us, the descendants of people who learned how to live with a moving horizon. Next, we turn our eyes upward, back to a time when the night sky stopped being only a wonder and became a tool. Between roughly 9,500 and 7,000 years before the present, scattered groups of humans around the world began to treat the heavens not as stories but as systems. They were still nomads or early farmers, but something new had entered the human mind, the idea that time could be measured. When did the night sky become a calendar instead of a mystery? For most of human existence, time had been sensed rather than counted. The passing of seasons could be felt in the tilt of light, the behaviour of animals, the scent of plants after rain. But at some point in the early Holocene, the sky became a record, one that could be read, anticipated, and used to plan. The first evidence of that shift isn't carved into stone temples or recorded in texts. It's scratched into bone. One of the oldest known examples comes from the so-called Ashango bone, found near the headwaters of the Nile but dating much earlier, perhaps 19,000 years before the present. Covered with incised notches grouped in specific sequences, it may represent lunar cycles. Its later counterparts, appearing around 10,000 years ago, continue this same pattern. a fascination with counting not for trade, but for rhythm. Some of these tally bones correspond to 29 or 30 marks, the length of a lunar month. Whether they track the phases of the moon, menstrual cycles, or hunting intervals, they show the same leap, from observing change to abstracting it. By 9,000 years ago, that abstraction was being written across the land itself. In the Nubian desert of southern Egypt, at a site now called Nabta Playa, archaeologists discovered something that at first seemed impossible. A stone circle aligned with the stars, built by pastoralists long before the pyramids, long before even writing existed. The site lies in what is now a dry basin, but during the early Holocene it was a seasonal lake ringed by grasslands. Here, herders gathered during the summer monsoon, bringing cattle and gathering under the open sky. Among the hearths and pottery fragments stand upright sandstone slabs, some weighing several tons, arranged in radiating lines. A smaller inner circle, carefully placed, marks astronomical alignments corresponding to the rising of certain stars at the summer solstice. When researchers from the University of Colorado analysed the orientation of those stones, they found something remarkable. The alignment fit the position of Orion's belt and the star Sirius as they appeared around 6,500 years before the present, suggesting that the people who erected them were not guessing, they were measuring. They noticed that the same stars reappeared in predictable rhythms with the seasons. Sirius rose in the dawn sky just before the rains returned, announcing water and life. The sky had become a signal, not just a spectacle. What makes Nabta Playa so fascinating is that it represents a society in transition. Not yet urban, not yet agricultural in the strict sense, but already sophisticated in its understanding of time. The herders who built it were observing cycles beyond their own lifetimes. That kind of patience, tracking the sun and stars over decades to mark their return, requires generational memory. To do it, you must think like both an individual and a lineage. The circle of stones became in effect a clock that spanned generations. Across the world, similar shifts were happening in quieter forms. In Mesopotamia, early farmers began orienting houses and fields towards sunrise or sunset points, suggesting attention to solstices and equinoxes. In China's early Neolithic sites such as Hemudu and Jiahu, post holes show consistent east-west alignments, as though buildings were being placed with the sun's path in mind. Even in Europe, long before megalithic monuments, simple stake rows and pit patterns indicate observation of seasonal light. Humans were beginning to live not only in time, but with it. What changed was not the sky, but perception. For the first time, people understood that the same motions above governed cycles below. The floods, the harvest, the migrations of animals. Time became externalized, no longer just the pulse of the body or the memory of weather, but a pattern that could be marked and shared. The night sky became a communal document, visible to all, unchanged across generations. At Nabta Playa, this awareness took physical form in ritual. The stones there were not merely observational tools, they were embedded in ceremonial activity. Excavations revealed hearths filled with burnt offerings and cattle burials nearby. Firelight flickering across those slabs must have transformed the night into a kind of theatre, where cosmic order was mirrored in human order. When the rains failed or the monsoon shifted, people could look to the horizon and remember that the sky itself carried meaning. The same mental shift is visible in smaller artefacts too. In Central Africa, not far from the Nile basin, engraved shells and bones show tally marks grouped in 3s, 4s, and 7s, perhaps attempts to divide time into manageable portions. In the Near East, the earliest calendars of the moon may have guided planting and herding. These patterns reveal something subtle but profound, the birth of anticipation, the ability to plan not just for tomorrow but for next season. Time became a landscape humans could navigate. Archaeoastronomers often describe this period as the dawn of temporal consciousness. It's not that people suddenly discovered time, they lived by it for millennia, but that they began to record it, to externalize the invisible rhythm of the cosmos into durable form. A bone, a stone, a horizon, each became a tool for remembering what would come next. This ability to map time outside the mind is what eventually made everything else possible. Agriculture, architecture, history itself. The most haunting thing about these early calendars is how quiet they are. No inscriptions explain them, no myths survive intact. All that remains are alignments, angles, and marks that imply long observation. Imagine watching the same sunrise point shift slowly along the horizon, year after year, realizing it stops at two extremes and returns. That discovery would have felt like uncovering a heartbeat in the sky, a reassurance that the world had order after all. The significance of this discovery is easy to underestimate because it's so fundamental. Before measured time, life was reactive. After it, life became predictive. Knowing when the rains would return meant security. Knowing when the river would flood meant planning. Knowing how long until the stars reappeared meant hope. The human relationship with uncertainty began to change. The cosmos became a clock, and for the first time we could read it. At Nabta Playa and similar sites, the builders eventually left as the Sahara dried, but their knowledge did not vanish. The idea of aligning the sacred and the practical with the heavens travelled with them. Thousands of years later, along the Nile, that same awareness shaped the calendar that timed the flooding of the river, the planting of crops, and the rituals of kingship. The stone circle in the desert was not a dead end. It was a beginning. Elsewhere, in the valleys of China, in the caves of Europe, and across the Pacific, skywatching took unique forms, orientations to rising constellations, to seasonal winds, to lunar shadows on cliff faces. What ties them together is the shared realization that time could be trusted. Once humans began to map the sky, they could also map themselves. When you stand under a dark sky today, one clear enough to see the Milky Way stretching like a river, you're witnessing the same view that guided those first observers. The same stars that marked their seasons still rise and set in the same rhythm, unchanged across 10,000 years. It's easy to forget that this stability, this dependable repetition, is what allowed civilization to exist. Without predictable time, there can be no memory worth keeping. And yet, what's humbling about this chapter of prehistory is how little we truly know. The alignment of stones at Nabta Playa, the notches on bones, none come with instructions. We interpret them through patterns, but the meaning behind them remains half buried in silence. Maybe the builders weren't just measuring the sky. Maybe they were listening to it. In a way, the stars gave humans something priceless, a mirror of eternity against which we could measure our fleeting lives. To watch them rise and fall in unchanging cycles was to realize that time has two faces, one infinite, one human. From that realization came everything that followed: calendars, rituals, memory itself. When did the night sky become a calendar instead of a mystery? Somewhere between the stones of a vanished lake and the marks on a carved bone, humans looked up and saw not chaos but continuity. The sky became an equation that needed no numbers, a pattern written in light that still waits for us every night. Tonight, we follow a trail not carved in stone or ink, but one that glitters faintly in the dust. Obsidian, shell, and jade green stone that move from mountain to plain, from one valley to another, long before writing, long before wheels or roads. Between 9,000 and 7,000 years before the present, humans who had only just begun to settle were already connected by invisible threads of exchange. They traded tools, ornaments, pigments, and perhaps ideas. The question is simple but vast. How far could an idea travel without a road? Archaeology has a way of revealing movement without motion. When scientists trace the source of a material and find it far from where it naturally occurs, it's like finding a footprint in time. Obsidian, the glossy volcanic glass formed when lava cools too fast, became one of the earliest global indicators of trade. It fractures into edges sharper than steel and gleams like frozen smoke. But its volcanic origins make it rare and easily traceable. Each volcanic source has a distinct chemical signature, allowing archaeologists to map the movement of its fragments with remarkable precision. And when they did, they realized something stunning. In the early Holocene, people were already moving this material across hundreds of kilometers. One of the richest sources was the twin peaks of Bingöl and Nemrut Dağ in eastern Anatolia, regions that today lie deep within modern Turkey. From these mountains, obsidian travelled westward across the plateau, turning up in Neolithic settlements like Sayonu, Aşıklıhöyük, and even as far as central Anatolia's great proto-town of Çatalhöyük. Each shard tells a story of connection, of journeys through rugged terrain, of rivers and passes that served as corridors of exchange long before formal trade existed. What's remarkable is that these movements weren't random. Archaeometric studies show consistent patterns. Certain sites acted as redistribution centres, suggesting established routes and mutual agreements. There were no coins, no merchants, no written contracts. Yet somehow, the glassy black stone from a volcano hundreds of kilometres away became commonplace in homes, workshops and graves. That means relationships, stable, recurring, remembered. To the east, along the Zagros Mountains of modern Iran and Iraq, another network mirrored this one. Here, obsidian from sources like Nemrut Dağ and Armenian uplands flowed down into the valleys of the Tigris and beyond, linking highland foragers and lowland farmers. At sites like Jarmo and Tepeguran, small bladelets of obsidian sit alongside local chert and limestone tools. Their presence means more than trade. It means contact between ecological zones, between different ways of life. The highland herders and the riverine cultivators exchanged more than goods. They exchanged adaptation strategies, survival techniques, perhaps even myths. Farther west, in the Balkans and Aegean, another material began to trace human connection. Marine shells. They appear in burials, pendants, and decorative beads at inland sites hundreds of kilometres from the sea. Each shell is a fossilised signal of movement. The Mediterranean cowrie, the spondylus shell with its deep purple sheen, both show up in inland Europe and Anatolia by 9,000 years before the present. These shells were not tools. They had no practical use. Their value was symbolic, aesthetic, maybe even spiritual. And yet, they moved along the same pathways as the obsidian blades. The trade in beauty came as early as the trade in survival. At near Nicomedia in northern Greece and Lepensky Vir on the Danube, spondylus shells appear alongside river fish bones and carved limestone sculptures. The contrast is striking, marine life and river life mingling in the archaeological record. These were not isolated valleys, they were nodes in a living network. Some scholars suggest that spondylus may have served as an early prestige item, exchanged to mark alliances, marriages, or shared rituals. Whatever its purpose, it shows that the first complex social fabrics were woven not from bureaucracy, but from trust and repetition. One of the most fascinating aspects of this early trade is its simplicity. There were no caravans or ships as we think of them, just chains of contact. A group might travel 2 or 3 days to a seasonal meeting place, exchange what they had, and return. Over generations, those short hops connected entire continents. An obsidian flake might pass through 20 hands, a shell through 30, until they arrived in a village where no one had ever seen the sea or a volcano, but where both were represented by a single gleaming object. In Anatolia, excavations at Çatalhöyük provide a vivid snapshot of this connectivity. Within the tightly packed mud brick houses, archaeologists found caches of obsidian tools and ornaments, some in workshops that appear to have specialised in their production. Microscopic wear analysis shows that obsidian from different sources was used for different tasks: coarse local stone for everyday cutting, fine distant glass for ritual or craft. That distinction suggests not only trade, but cultural value placed on rarity and origin. People knew where things came from. Provenance mattered long before we had a word for it. Meanwhile, in the mountains of northern Iran, communities at sites like Ganjdare and Ali Kosh were also importing materials from afar. Obsidian there came from at least 3 different sources, implying multiple directions of contact. The same settlements yield marine shells and greenstone beads, showing a blend of local and exotic. Each object, small as it is, records the scale of early human geography, not just how far we could travel, but how far we could imagine. Greenstone, serpentinite, jadeite, and similar minerals adds another dimension to this picture. Unlike obsidian, which was valued for its cutting edge, greenstone seems to have been prized for colour and texture. Its cool lustre between blue and olive had a life of its own. In the Balkans, polished axes of greenstone appear in sites where no such rock exists nearby. These were prestige tools, too beautiful and too carefully made to be purely utilitarian. In some cases, they appear unused, perhaps buried as offerings. The pattern repeats across Eurasia. Stone mined from one mountain ends up in another far away, travelling through unseen social maps. From a modern perspective, these exchanges may look primitive. No written contracts, no ledgers, but in reality they represent something profound, the emergence of trust networks that spanned ecological and cultural boundaries. To exchange obsidian or shell, one needed mutual recognition. A trader in the Zagros highlands had to trust that someone on the Anatolian plain valued the same shine in the same way. That shared understanding, repeated over centuries, became a kind of unwritten language, a grammar of value carried in the hand. What's equally fascinating is how consistent these roots were. Modern chemical fingerprinting of obsidian artifacts shows that certain trade corridors lasted for millennia. The same volcanic source that supplied obsidian to a site in 8000 BCE was still supplying it 2000 years later. That kind of continuity implies cultural memory, knowledge passed not just through families, but through communities that spanned generations. One can almost picture it. A seasonal gathering on a river terrace, small fires flickering as different groups arrive, bringing obsidian from the mountains, shells from the coast, pigments from riverbeds. There is barter, yes, but also conversation, exchange of stories, songs and rituals. The trade becomes an excuse for contact, and contact becomes culture. The circulation of materials becomes the circulation of meaning. This was trade before writing, but also before hierarchy. There were no kings or merchants, only travellers and neighbours. The economy was trust-based, embedded in kinship and reciprocity. And yet, the outcomes were astonishingly complex. By 7,000 years before the present, archaeologists can trace materials across distances of more than 1,000 kilometres. The seeds of globalisation were already germinating in a world of huts and hearths. Even more striking is how trade affected technology itself. Access to exotic materials like obsidian encouraged experimentation. Pressure flaking, polishing and hafting innovations spread along with the material. Ideas moved with objects. A blade wasn't just traded, it carried a lesson about how it was made. Cultural diffusion preceded writing by thousands of years. The map of early trade routes is also a map of shared intelligence. What's humbling about this is how invisible it once was. For most of history, archaeologists saw early farming societies as isolated, simple and static. Only recently have chemical and isotopic methods revealed how dynamic they were, how objects flowed like rivers, reshaping communities far apart. Each obsidian flake is a fragment of human communication. Each shell bead is a word in a forgotten conversation. So how far could an idea travel without a road? Farther than we imagined. Across mountains and seas, through generations and languages, carried by hands that understood the same glint of glass, the same colour of stone. These early exchanges remind us that civilization didn't begin when we built cities. It began when we built relationships. Long before there were markets, there was curiosity. Long before profit, there was beauty. Now we're going somewhere older than temples and long before names for gods existed. Between 10,000 and 7,000 years before the present, something subtle happened inside the human mind. In a world of ice retreat and green rebirth, of animals returning to valleys and rivers swelling again, our ancestors began to see themselves reflected in the living landscape, and the landscape reflected back. They carved what they saw. They built with meaning as material, and so belief began not as dogma, but as ecology's mirror. When archaeologists study this early spiritual turn, they find no scripture, no doctrine, and no single symbol that rules them all. What they find are hybrids. Human hands shaping animal forms, antlers sprouting from skulls, bird-headed figures dancing beside the hunt. Across Anatolia, the Levant, the Balkans, and the river plains of what is now Iran, stone and clay preserve a moment when the line between creature and concept began to blur. The world was alive, and every other living thing had a mind of its own. This worldview, what anthropologists later call animism, was not primitive fantasy. It was an adaptive technology. To live surrounded by predators and prey, forests and droughts, was to live in negotiation with forces beyond control. The early Holocene was unstable. Climates shifted. Rainfall patterns changed. Plants moved northward. Seeing agency everywhere might have been a way of making sense of unpredictability. If the wind had intention, you could ask it for mercy. If animals had souls, you could thank them when they died. Animism gave chaos a grammar. Evidence of this worldview lies in the small things first. Carved bone figurines and stones etched with eyes, horns, and hands. The famous limestone statues from central Anatolia's site of Çatalhöyük, though later than 10,000 BCE, carry echoes of even earlier traditions. But before that, scattered through northern Mesopotamia and the Zagros foothills, we find simpler tokens. In the caves of Zazi and Shanidar, bone carvings of ibex and aurochs show not hunting trophies, but deliberate abstraction, their horns exaggerated, their faces human-like. In the Levantine Natufian sites, decorated gazelle bones and pierced fox teeth worn as necklaces suggest relationships that were not purely economic. These were not just food sources, but partners in survival, perhaps protectors or ancestors. Further north, in Anatolia's uplands, the monumental carvings of Göbekli Tepe and Karahan Tepe present the clearest image of this mindset. The pillars there, each shaped like an abstract human, are surrounded by reliefs of scorpions, snakes, vultures, wild boars, and cranes. The animals are not decoration, they dominate. Their posture is confrontational yet ordered. Archaeologists have long debated what these scenes represent, but one thread emerges consistently. The builders saw no boundary between human and non-human. To depict oneself as a pillar among beasts was to acknowledge that the wild world shaped you more than you shaped it. Even outside monumental sites, this same symbolic ecology appears. In southeastern Anatolia, small stone amulets shaped like foxes, leopards, and birds of prey appear in domestic contexts. Their wear and polish suggest they were carried, perhaps as talismans or companions. At Boncuklu Höyük, one of the earlier settled villages, residents buried small animal figurines beneath house floors, maybe as offerings or guardians. The animals chosen, hares, waterfowl, cattle, mirror the local environment, implying a direct negotiated relationship with familiar species. The divine, in this period, still had fur, feathers, and breath. It's easy to romanticize this as pure mysticism, but there's a hard logic underneath. Belief served survival. By embedding respect into daily life, these early societies maintained balance with their ecosystems. Killing an animal or cutting a tree wasn't casual, it carried a ritual cost. Archaeologists at sites in the Jordan Valley and Zagros find animal bones deliberately arranged in circles or burned in patterned deposits as if closing a conversation. The rituals might have been simple thank yous, but they created a feedback loop between action and meaning. Animism, in that sense, was an early environmental code, a spiritual language for sustainability. But somewhere within those rituals, abstraction began to take hold. When a hunter painted a deer-headed figure or carved a bird person, it was more than symbolic gratitude. It was creative cognition. The mind was experimenting with combinations, human intention joined with animal strength, vision, or fertility. This fusion marks the beginning of what we might call proto-deities, not yet gods, but shapes of reverence. The imagery repeats across continents. In the Balkans, anthropomorphic figurines bear owl eyes and snake-like bodies. In Iran's highlands, a steer-type carving shows a human torso merging into a lion. In the Anatolian plateau, foxmen and crane spirits dominate stone walls. Across these regions, the same cognitive threshold was being crossed independently. Belief was shifting from observation to personification. Why animals? Because they were the most obvious embodiment of power, mystery, and continuity. They migrated with the seasons, disappeared, returned. They could kill or feed. They represented cycles in motion. In a world where the seasons were newly stabilizing after the Ice Age, animals became both calendar and teacher. The aurochs taught endurance, the vulture transformation, the serpent renewal. To merge with them in art was to merge with the forces that ruled existence. Another clue comes from burial practices. In the early Holocene, graves sometimes include animal parts placed beside or upon human bodies, fox jaws near skulls, bird bones over chests, cattle horns framing tombs. This wasn't decoration, it was identity. The buried person might have belonged to a lineage symbolically linked to that species, a totem group that traced its ancestry to an animal guide. Such systems, known in ethnography from later societies, may have deep roots here. If so, then what we're seeing in these burials is the social structure of belief, kinship not only among humans but between species. One of the most striking finds comes from Ain Ghazal in modern Jordan, where plaster statues from around 9,000 years ago show elongated faces with almond eyes and inlaid pupils, eerily lifelike. Some figures have dual faces or animal-like features, broad snouts, horn-like protrusions. These were not portraits. They were embodiments of ancestral spirits or intermediaries between living and non-living, animal and human. The act of modelling them from lime plaster, a material made by controlled fire, was itself transformative, turning earth into stone, impermanence into permanence. Belief was becoming tangible. Meanwhile, in the wetter heartlands of Mesopotamia, clay figurines tell a gentler story. The so-called mother goddess figures, often exaggerated in form, seated and holding animals, are less about dominance and more about continuity. They suggest fertility, abundance, and the integration of human life with the cycles of birth and decay. Some scholars see them as ancestors to later goddesses, but in this context they were likely archetypes of the living environment itself, Earth as being, not person. If we strip away later theology, what emerges is something deeply practical yet poetic, a belief system that encoded survival rules as reverence. The more stable the environment became, the more abstract the spirits grew. As rivers and rains grew predictable, the sense of cosmic uncertainty shifted from immediate fear to metaphysical curiosity. The world was still alive, but now it could be studied through symbol. The same brain that once read predator tracks on mud now read patterns on stone. What's humbling is that we can only glimpse this transformation through fragments. The figurines, the carvings, the animal remains, they speak but quietly. We can't know exactly what these people believed, only that belief itself was taking form as a kind of social glue. To see a wolf not just as prey but as protector was to weave empathy into identity. And that empathy, paradoxically, may have made us more cooperative, more adaptable. Spiritual intelligence in this light wasn't an illusion of comfort. It was a survival strategy. By 7,000 years before the present, the first villages of the Near East were filled with images that no longer strictly mirrored the natural world. Faces lengthened into abstraction. Bodies became symbols. The fox, the bull, and the bird turned from neighbours into metaphors. The living world had been internalized, translated into concepts of power, rebirth, and fate. The gods were still animals, but they were learning to speak in human shape. Whether you're lying awake beneath a ceiling or under the quiet hum of the ocean in your own head, you're with Sleepless Homo. Tonight we surface, not to look back, but to listen. The waves above us have always carried the same rhythm, the same hum of impermanence. 10,000 years ago the shoreline shifted and a world drowned in silence. Now we stand on coasts built from what the last flood left behind, measuring our own rising seas, wondering, if the first civilization ended in silence, what might ours sound like underwater? Every era believes it is the centre of the story, that its inventions are unique, its fragility new. But the deeper we excavate, the more familiar the pattern feels. When the ice retreated at the dawn of the Holocene, the world's edges blurred. Continents became islands, valleys became bays, and whole ecosystems were swallowed. Yet in those shifting landscapes, people built, traded, dreamed, and adjusted. They didn't know they were living through climate change. They only knew the river was closer this year, the forest thinner, the summer longer. And still, they adapted. The evidence we've found, stone, shell, ash, pigment, shows not panic, but persistence. Archaeology is not about answers, it's about humility. Every site, every tool, every carved animal is a reminder that intelligence doesn't always announce itself loudly. We keep discovering complexity where we were sure there was none. A circle of stones in a desert turns out to be a calendar. A buried hearth reveals a recipe for survival. A forgotten coast hides a drowned city that no one remembers building. Each find whispers the same quiet correction. You were not the first to wonder. The phrase, advanced civilization feels less certain the longer we look at time. If advanced means the ability to measure the stars, build with precision, plan harvests, or encode meaning into symbols, then the blueprint of advancement was written before the cities, before writing itself. The people of the flooded dawn were already measuring, mapping, trading, building, and believing. They just left their records in materials that the ocean could take back. Maybe the real measure of advancement isn't technology at all, but continuity, the ability to adapt without erasing what came before. Modern humanity, with all its satellites and algorithms, still depends on ancient rhythms we didn't invent. The spin of the Earth, the pull of the moon, the tilt of the seasons. Those are the first clocks, and they are still keeping time for us. What has changed is not our intelligence, but our perspective. We no longer see ourselves as part of the ecology that shaped belief, only as its managers. 10,000 years ago, we whispered to rivers and stones. Now we engineer them. When the sea levels rose at the end of the Ice Age, they did so slowly by human standards, but catastrophically by generational ones. Every few decades, a coastal camp disappeared. Every few centuries, an island sank. Stories became the only way to remember the shape of what was lost. The flood myths that survive across cultures, from the valleys of Mesopotamia to the islands of the Pacific, might not record one disaster, but a long accumulation of grief. The memory of watching the world fill. Today we have data instead of myth. But data is only the modern form of awe. It still tells us that the waters are rising, that the edges of our world are eroding again. The parallel is unsettling, but also grounding. The last flood didn't erase humanity. It reshaped it. The next one will likely do the same. Every generation learns the same lesson the hard way, that permanence is an illusion. When we look at submerged landscapes, Doggerland under the North Sea, the Sunda Shelf beneath Indonesia, the plains of the Gulf now hidden under salt water, we're not looking at failures. We're looking at the cost of existing on a living planet. If you could stand today on one of those ancient plains, drained of its water, you'd see the ghosts of order, hearths, pathways, carvings, not chaos. People moved their lives upslope, carried what they could, and went on. There's something comforting in that. The resilience isn't mythical, it's mechanical, biological. It's us. The same nervous system that felt the warmth of the first hearth still feels the warmth of electricity. The same curiosity that traced the stars still builds telescopes. The continuity is not cultural, it's cognitive. We are the same species staring at the same sky, only with better tools for pretending we control it. When we call ourselves advanced, what we usually mean is visible. We measure advancement by scale, by monuments, by records, by noise. But if the early Holocene taught anything, it's that the most enduring forms of intelligence are quiet. Fire, memory, adaptation, cooperation, all the things that kept those early societies alive are the same things that sustain us now. Our cities are simply larger versions of their hearth circles. Our digital networks are echoes of their trade routes. Their climate was unstable, so is ours. The only difference is that we can see the flood coming in pixels instead of waves. Perhaps that's the haunting part. 10,000 years ago, the flood arrived before humanity could warn itself. Today, the warning comes before the flood, but belief in data has replaced belief in story. We are rational but restless, informed but unsure how to feel. Maybe that's why we keep turning back to myths. Noah, Utnapishtim, Atlantis, the flooded dawn. Stories that let us frame the unimaginable. They remind us that the idea of the end is never really the end, just a rearrangement of what survives. Underwater archaeology has a phrase for this: the preservation paradox. What disappears from view sometimes endures the longest. The oxygenless layers beneath the seafloor protect what the surface destroys. Wooden tools, seeds, fabrics, even footprints can survive in silt for millennia. The world we lost is still there, sealed in silence, waiting for us to listen differently. Perhaps one day divers will find traces of us in the same way. The outlines of towers and harbours turn to reefs and sediment. Civilization isn't erased by water, it's translated into another medium. If we could ask the people of the flooded dawn what they thought as the tides rose, maybe they'd tell us that the flood never felt like an event. It was simply time moving, nature shifting shape. The same could be said for us. The difference is that they accepted change as participation. We resist it as punishment. But to live on Earth is to live with flux. To survive it is to remember that we've done it before. In that light, the question, what if Earth had an advanced society 10,000 years ago, becomes less about technology and more about continuity? Maybe the real secret of their advancement wasn't lost knowledge, but composure, the ability to adapt without despair. They watched their landscapes drown and still built new lives on higher ground. Their innovation was not in machines, but in mindset, in patience, in observation, in the humility to remain small within something vast. That humility is what archaeology, at its best, restores to us. Every excavation is an act of listening to those who no longer have voices. Every carbon date is a translation of time's handwriting. The work is slow because it must be. To study what's buried is to acknowledge that meaning accumulates through sediment, one layer of dust at a time. In that patience lies a kind of wisdom modern culture keeps forgetting, that progress without memory is just motion. When the water finally covers the last ruins of our own age, what will survive of us? Glass, plastic, satellite debris orbiting in silence, or maybe something quieter, the signal patterns we left behind, encoded in the planet's chemistry, in the altered rhythms of its air and oceans. The next species to study us might not find monuments at all, only evidence of imbalance, of speed. They might call us advanced, or they might call us noisy. And yet, even that thought carries comfort. The same way the first flood didn't erase us, neither will the next. What endures is curiosity, the compulsion to look backward, forward, inward, the drive to make meaning, even in decline. That's the true continuity between their dawn and our dusk. Not technology, not cities, but awareness. The ability to feel awe in both creation and collapse. If the first civilization ended in silence, maybe ours will too. Not as tragedy, but as return. The water will rise, the lights will fade, and the earth will go on writing its slow autobiography in sediment and tide. Somewhere beneath that calm surface, a future archaeologist, or something like one, might hold a fragment of glass or ceramic, wonder who made it, and imagine the noise of our world. That moment of imagination will make us human again, even if we're long gone. The flooded dawn isn't a warning, it's a mirror. It shows us that endings are only quieter beginnings. Every shore we stand on was once someone else's ocean. Every flood is a continuation of a story that never stopped. Thank you, fellow Sapiens, for wandering this timeline with me, for drifting into deep time, for slowing down and remembering. If this helped you fall asleep, helped you study, or simply helped you step out of the noise for a while, thank you for being here. If you think more people should know this story, you know what to do. Like, subscribe, share it with the Sapiens in your life, and tell me, are you listening before bed, while working, or somewhere in the world I can only imagine? And as always, stay curious, stay calm. I'll see you in the next story.